All right. Good morning and welcome everyone who's joining us for the first time, and welcome back everyone who's joining us from the last 2 days of this amazing conference. Today is day three of the DataEngBytes Data Engineering Conference Australia. My name is Aditya and I'm a data engineer at OpenPay. And with me today, I have Ingrid Anzola.
Good morning, Aditya. Thank you for having me. My name is Ingrid Ansola. For those who don't know me, I'm the head of data platform at Shipit, and I will be joining Aditya today. We will be hosting your morning session. It's great to have you all here. How good has been so far, Aditya, right?
Yes, some interesting talks and intriguing talks, I would say. And I'm really enjoying and looking forward to today as well.
Yeah, absolutely. Looking forward to our the morning lineup. Tell us a bit about it, Aditya.
Yep, that is a good question, and I will use it as a segue to talk about today's lineup. Starting today, Simon O'Toole would be giving us our keynote at 10:10 a.m., who's going to be talking about adventures in astronomical data pipelines, followed by Jessica Laughlin, who's going to talk about Gone streaming, DBT, and Materialize. Then we're going to have a short break, followed by Stephen Weingartner, who's going to talk about a single data platform for all of your workloads. And then we're going to end today's morning session with a talk from Tejas Manohar, who's going to talk about putting your data warehouse to work, about reverse ETL and operational analytics. Who?
Wow, that's exciting.
Yep.
Yeah,
Yep.
and this wouldn't be possible without the support of our amazing sponsors. So give a big shout out to our sponsors today: Snowflake, Fivetran, Databricks, Microsoft Azure, Amazon Web Service, Imply, Versers, DBT Labs, ThoughtWorks, High Touch, Microsoft Reactor, Yao Conference, and Cloud Shuttle. How good is that list of sponsors?
Yeah, I think that, and I really thank all the sponsors from my side as well for supporting this conference and putting data engineering and sharing knowledge with everyone. Uh, Also, I don't think we should forget our brilliant team of organizers, without whom this conference wouldn't have been possible. And a huge shout out from my side to Peter Hansens, who's been the backbone of this organizing team.
Oh yeah.
We've also had our great committee, uh, Nitish Matthew from Afterpay, Rohan Dupelia from Atlassian, our very own Ingrid Anzola from Shipit, and Jess Flanagan as well.
Thank you, Aditya. Well, we are preparing to start our talks today, but before we go ahead, I would like to remind you how you can interact with us. So you can engage with our speakers through our YouTube chat where you are watching us, or you can engage on the conversation on Slack. If you post questions on the Slacks, our moderators will make sure that we engage the speakers and give you the right answers.
Yep. I highly encourage all of you to use the YouTube chat to post in your questions, comments, and use discussion forums to talk more about to the speakers. But while doing this, I would also like to remind everyone that we have a code of conduct that we would ask everyone to follow. We do not tolerate any kind of harassment and discrimination based on any of the factors mentioned. And any such activities, if you do notice, please let us know. Please let us know the organizing committee, and we will take relevant actions. Overall, just be a respectful online citizen and be kind and friendly to everyone.
As you know, we are hosting this conference today from Australia. So we would like to begin today acknowledging the traditional custodians of our land and pay our respects to their elders, past and present. I acknowledge the traditional custodians of the various lands on which we work today and the Aboriginal and Torres Strait Islanders people participating in this conference. I pay my respects to elders past, present, and emerging, and recognize and celebrate the diversity of Aboriginal peoples and their ongoing cultures and connections to the lands and waters of Australia. Without further ado, we can now start with our first speaker. Tell us about it, Aditya.
Yes, now that we have got the announcements out of the way, our first keynote for today would be given by Simon O'Toole, who's going to talk about From Telescope to Data Center and the Adventures in Astronomical Data Pipelines. A quick bio about him. He's got a PhD in astrophysics. He's based in the Australian Astronomical Optics Group at Macquarie University and is leading projects to build a next generation astronomical data archive. He's also got experience in managing data at the Australian Astronomical Observatory. Um right, Simon, welcome. Good morning.
Morning. How you going?
Awesome. How are you going? You're joining us from Sydney. How's the weather
Yep,
there?
that's right. That's right. Yeah. It's a bit cloudy, but it's supposed to be warm. So hopefully it picks up a bit.
Yeah. Without further ado, we would hand it over to you, Simon, and you can start with your presentation right away.
Okay, great. Thank you. Okay. So I'm Simon O'Toole from Macquarie University, Australian Astronomical Optics, also known as just the AAO. So that's how I usually refer it as. I'm going to be talking about some of the work that we're doing in the Data Central project. It would be remiss of me to not mention our funding agencies. We are funded through public money through the NCRIS scheme there you see on the far left. That's the National Competitive Research Infrastructure Scheme, which is part of the Department of Education, for the Australian government. And that money is distributed by Astronomy Australia Limited, which is sort of an overarching body in astronomy across Australia that distributes money for all sorts of different projects, ranging from ours to the Square Kilometre Array project, to some of that money, and access to supercomputers at NCI, which is also listed there. That's the National Computing Infrastructure. That is a system based out of ANU, Australian National University, that hosts one of the largest supercomputers, or the largest current supercomputer in the country, and a lot of support for researchers and academics around Australia. We also do collaborate with the Australian National University more broadly in this space. And I just thought I'd highlight this beautiful picture taken by Michael Goh in Western Australia of the Milky Way galaxy that you see there. The sort of the band that's hooking across the sky over the pinnacles in Western Australia. Um, so that is the romantic side of astronomy. The real side is a lot more data intensive. So who am I and what is Data Central? So I'm a former research astronomer, as was mentioned. I have a PhD in astrophysics, but about almost 9 years ago, I switched in to become more of a data engineer and manager, and have been at the AAO. I started there as a research astronomer and then moved across. The AAO used to be part of the Australian government, the Department of Industry, Innovation and Science. It's had multiple names, but that's what it was when we left. It's now the Department of Industry, Science, and Energy and Resources. But in 2018, we moved over to become part of Macquarie as part of sort of a funding rearrangement. So Data Central is the e-research platform that we've been building for the past 6 years, and it's developed to help researchers manage their data, publish it, and share, as well as analyze it. We aim to support the full data lifecycle, and primarily we work in astronomical data. So that means from the time the data comes off the telescope, which is what I'll be talking about today, but we're also moving into other areas of research. So that might include laboratories or other field work, and then take that through, support the teams that are working on the data, all the way through to their journal articles, which are published, peer-reviewed science works, and then onto the data archives, so that data is shared across all researchers. In astronomy, this is a big thing. It's basically how astronomy is done. You take your data and share it. But in other research areas, data may be proprietary or or sort of kept close to people's chests for a little bit longer, and only published data is made available. So the background and motivation to astronomical data. So astronomy data is classic. You can consider it as classic big data. We have the 5 Vs, although when I started in all of this, it was the 3 Vs. But we're really moving into the 5 Vs now. We have a volume, so the Anglo-Australian Telescope, the AAT. Over the last 47 years, it's collected about 15 terabytes of data. The data rates early on were very, very small. We basically, if you can imagine your digital camera having only 1 pixel, that's what the data coming off some of the detectors was like in the early years, but now we have many megapixels. So we're typically anywhere between 8 and 16 megapixels per image that's taken now. So that 15 terabytes, the first 30 years or so was approximately 1 terabyte, and then it's been increasing. The data rate has been increasing from the AAT for the last, say, few years, maybe 5 years. We've really probably had at least 10 of those 15 terabytes in that time. However, the AAT is nothing compared to radio telescopes, and then so current and future. The 40 petabytes is 8 years of the Murchison Wide Field Array, which is a radio telescope, which is leading up to the big one, the Square Kilometre Array. So 40 petabytes is actually not the amount of data they've taken. That's the quota that they have at the Pawsey Supercomputing Centre, and 40 petabytes rather of data is what they're able to host there. But then in the next sort of decade or so, we'll see the Square Kilometre Array, and in 1 year, the Square Kilometre Array will collect around 600 petabytes of data. So that's when we really hit the exabyte regime, and we start talking about exascale science. Velocity. So obviously you can imagine that at the AAT, where we are only collecting terabytes of data or storing terabytes of data, maybe 1 or 2 per year, we're taking not very much data per night, no more than around about 15 gigabytes per night at the AAT. However, when we come to the Square Kilometre Array, the SKA, will be more in the regime of 1 terabyte per second. And that's how we get to our 600 petabytes per year. And the data rates are so large that we won't be able to store all of that data. So it has to be reduced and processed basically at the telescope before it can even be moved down to the big data arrays, which will be hosted in Perth. We also have a large variety of data, and the raw data here is, in many cases, it's really an image, but it's an image of a spectrum. So that's sort of, you can imagine the rainbow fingerprints of distant stars and galaxies. And then when you come to radio telescopes, they're often they can be a single pixel style data flow, similar to the early years of optical data, so data with mirrors, but also now large arrays of voltages and something called visibilities, which is a complex term that I don't even understand myself because I was never really a radio astronomer. And then the veracity, the 4th V, understanding and removing instrumental effects. If you consider when you take a photo with your phone, if you take it at very low light levels, so in dim light in the evening, for example, you end up seeing sort of like this grainy kind of noise pattern, particularly in the darker patches of your image, and that is the kind of effect that we need to remove, because that is hiding some of the very, very faint things. That the things that we're looking at here are very, very faint. You can't see them with your naked eye. You need very large mirrors and very large radio dishes, often many or tens or even hundreds of radio dishes to measure these objects out in the distant universe. And then the value, of course, of this data is just expanding human knowledge. You can take it at the high level, but also obviously these facilities all cost a lot of money to set up and to maintain. So the cost per observation, you can also consider each observation and the data with it has a value, an actual cost value. So for the purposes of this talk, um, astrophysics can be divided into two parts. So you have time critical science. So that's basically things that go bang, which is the top little animation there, and then everything else. So there may not be a bang, but you may still need to have timely data. So something you may need to look at something and how it changes over time, over many days or years, or it may not really change at all, but you may want to still try and get as much data in a reasonable amount of time as you can. So here, as I said, we're focusing on the time critical for the sort of the main use case of this of my presentation here, but everything else is no less important. It's just a different kind of observation and different data and a different sort of science case. So I will probably use the term use case and science case interchangeably throughout this presentation. So what we're really talking about here are things that go bang. So they can be explosions, collisions, and mergers of things out there in the wide universe. And two of the key use cases are the merger of black holes and neutron stars. And black holes are things that you might get at the center of large galaxies, including our own Milky Way. There's a very large black hole, which is 1,000,000 times heavier than our own sun. And in some galaxies, they're even larger than that. They may be 100 million times larger than our own sun. And neutron stars are things that are basically at the end of a star's life. They'll either fade away, peter out, and fade away, run out of fuel, basically, or they'll be so large that they explode in a supernova, and those supernova explosions will either lead to a black hole or a neutron star, which is not as densely packed as a black hole. You don't have the same gravity. I mean, you'll probably have heard that black holes, nothing can escape a black hole, even light. A neutron star is not quite like that, but it is very, very dense. And so it's called a neutron star because all of the other parts of the atom, the electrons and neutrons, protons rather, all get squished together and become neutrons. And they form a very strange material indeed. And because of these collisions and explosions, etc., you need almost immediate observations. You need to know, if you want to understand what's going on, ideally you would capture the information before the explosion, and in some cases that's been done, but certainly as soon as possible afterwards. And then you might want to observe these objects for a few days or weeks or months uh, after the actual event has taken place. And then the data processing must also happen rapidly. You need to in order to understand the phenomenon, what it actually is that's happened, because oftentimes you don't have that information until you look at it afterwards. You want to be able to find out what it is very quickly to see if any follow-up is required, because there are some things that go bang out there that aren't quite as interesting, a little bit more commonplace. Especially within our galaxy, there are things called novae, so not super, and so they're stars that basically get very, very bright for a short period of time, but then they fade away, and then they stay as regular stars. There's no massive explosion in quite the same way. And these research fields are very, very competitive. To understand what's going on here, you can get it can be very, very prestigious, and you can end up on front cover of major magazines like Time, the front page of major international newspapers. For example, the New York Times is often something that people aspire to. as well as being able to publish their results in highly prestigious research journals. So in order to talk about astronomical data, we have to start talking about astronomical data formats. So observational astronomy and radio astronomy to some, or observational optical astronomy, which is mainly what I'll be talking about here, but radio astronomy also uses something called the Flexible Image Transport System format, or FITS. FITS is quite an old format. It's been around for over 30 years. It's quite standardized, although as you probably know, with most standards, it's all about the interpretation. And it's maintained by NASA at the Goddard Space Flight Center, and also in collaboration with the International Astronomical Union, which is the body that represents all astronomers throughout the world in every country. So it's a pretty simple format, FITS format. It consists of an ASCII text header, which is seen here on the right, and that comes in basically as key value pairs, or maybe you could. It's really it's a triple, not a tuple. It's a key, a value, and then maybe a comment as well, and that provides its own sort of challenges. And then you have your text header. So every FITS file has a text header, and there are a standard set of keywords or keys that are used. In the picture on the right there, you see the top sort of 16 or so are some of the standards. Some of them towards the bottom are standards, but some of them are very particular to the telescope or the instrument that was being used. And so that you can also, in a FITS file, you can not only have just your text header and binary image, which is the observation, but you might have multiple images and even multiple headers. So there'll be an extension, and so you have a primary image and header, and then extensions associated with it, and that may contain other information. It may contain variants or other information that was acquired during the observation, or it might be something that is done as part of the post-processing of the image. The extensions can be images, but they can also be binary tables. So basically, just a binary form of a table, not anything particularly fancy. And we do use other formats in astronomy. CSV files are remarkably common, particularly for transport, and HDF5, which is, I think, more of a research format. So you may not have come across that one. It's a hierarchical data format, and they're up to the 5th version of it. That's something that was implemented by geoscientists and atmospheric scientists, and that's often used to transport data around those two formats. And then we have started seeing a increasing uptake in something that you're probably more familiar with, the Parquet format, and that's used for storage. So data acquisition. So you have your telescope, whether it's a mirror like the Anglo-Australian telescope, the AAT, or radio telescopes like the SKA will be. There is also one at Parkes, very famously, the Dish in central New South Wales, that was involved in the moon landing, but it is still taking science data to this very day. So you take there are two components to observations. In order to observe these beautiful images here of a galaxy and a cluster of stars in a gas nebula, you need science frames. So that's where you actually point at the object that you're interested in, and then you need calibrations. And this is what I was talking before about with detector variations. You have variations which are sort of like a base noise level, and then variations that are really how the detector responds to light across the detector. So different pixels will respond differently, and often that happens in some kind of smoothly varying way. And so we want to remove that when we're talking about images. And then we also need, when we're talking about spectra, so the rainbow fingerprints I mentioned earlier, we also want to get the wavelength, the actual color information there. That's not something that comes, you need to sort of do a calibration and have some known wavelength source that you compare your observation to, and it passes through the same instrumentation through the same hardware. So the observations are made using a coordinate system. It's similar in some ways to, to latitude and longitude on Earth. And in fact, there is something known as galactic latitude and galactic longitude, but the reference system is different. Primarily, or in many cases, we'll use coordinates called right ascension and declination, and that's sort of related to azimuth and altitude, if you're familiar with sort of some of the naval terms, and it's defined using something called the World Coordinate Systems conventions, and these define how we map the celestial coordinates on the sky and then map them onto a detector, and all of the metadata around that, how what the reference points are, go into the FITS header, and so they can be read. And there are lots of libraries that you can use, Python in particular, but also R and C and other languages can read FITS headers and extract this information. So the problem that we have, though, so I've given you the background of what the data format is and everything, is that telescopes need to be in remote locations. For a radio telescope, it needs to be radio quiet. So you can't have mobile phones everywhere, smartphones. You can't have microwaves even. There's a famous story of an astronomical event that wasn't, because it turned out that someone had been running the microwave in the visitor lodge of the telescope that was being used. And so for several years, so all of these papers and even conferences about these strange events that kept occurring, and why were they only seen here? And it turned out it was actually microwave. So we can't have that information. You will see buildings are either very heavily shielded or there are no microwaves at radio telescope sites. And also, particularly for optical telescopes, it needs to be very, very dark. No artificial lighting. We should have no artificial lighting. So the problem is that data centers can't be that isolated. Peter mentioned, I think it was on Monday, that we have this problem that you need to be very far away from built-up areas in big cities. So central New South Wales, just outside of Coonabarabran, is where the AAT is, and the SKA will be primarily in remote Western Australia. So we need an efficient transport mechanism to move data these many hundreds of kilometres. So the case study for this talk is the Anglo-Australian telescope. The data there is typically, you might have multiple cameras, and they're 32 megabytes per observation, with multiple observations up to 4. So therefore 128 megabytes per observation of data. The telescope that you see here, this is a slightly old image, but it does pretty much still look like this. There's a bit of extra safety gear on it these days. There are 2 instrument control computers, depending on what instrument is being used, and that would sit at the very base of the telescope, or perhaps even in a room off to the side. And then you have a fiber optic cable or mirrors to direct the light into those rooms. And the control computers that control the instrument control the cameras as well. There is limited compute and storage capability on the mountain. And that's in part because it is just isolated, but also for a long time there wasn't much needed. The data sizes weren't large, and so there isn't really the capacity to host a large amount of compute on the mountain. And these days, not as many astronomers actually go to the telescope. Mostly now it's remotely operated from their home university. They're even starting to move to a model where in certain situations you may be able to run it from your home, but the control computer has a 4-headed monitor, so it's still primarily done at a university site. In the case of transient astronomy, so that's where I'm talking about the things that go bang, things that come and go very rapidly. Astronomers don't even go anymore. Someone else at the telescope will take the data for them. There is a small crew of staff who are always at the telescope to drive it. Basically, this thing weighs many hundreds of tons, and so you can't just have any old person come and use it. You need an experienced operator to run this telescope. So the problem is we need to move the data away from this remote site and process it rapidly. And this is research and university, so we actually have a very limited budget for this. So Siding Spring Observatory, it's 470 kilometers from Sydney and around about 650 kilometers from Canberra. There is a 10 gigabit pipe that comes from Siding Spring Observatory, which is where the telescope is, to the main trunk, which is Australian Academic Research Network, which is also known as AARNet. There's the pipe from the observatory connects to the main trunk at Coonabarabran and then comes down to Sydney and Canberra to NCI and the AAO, following various paths. So our solution, so we're using a system called Apache NiFi, which I'll talk about in a little bit, to move the data from the telescope to the AAO, which is just in North Ryde in Sydney, and to NCI, which is, as I said, part of ANU on the main campus of ANU. Then we've passed the FITS header using a Python script, and then place all of that metadata that we extract into a MongoDB and put the files themselves just on a file system. And then we have a system that allows astronomers to come and query the data and retrieve it as they need, and that's a system built using just React and Python with the Django framework. And then we authenticate because we do need to have some kind of access control, particularly for, I think, astronomers for the AAT get 18 months where no one else can access the data. They have to apply to access the data and then go and observe it. They have to put in a sort of a science case, and that gets reviewed by a panel. And so they have 18 months from the moment they take the data to the moment it becomes public to the world. And then we do data processing using a combination of Docker and bespoke software. And this allows us to improve the performance of what you'll see is quite old software. So here's the technology solution. So we have NiFi, MongoDB, CAS, and then React and Django plus Docker and the bespoke software I mentioned. So NiFi, if you're not familiar with it, this is from the NiFi website. It's an easy to use, powerful and reliable system to process and distribute data. And the name comes from the original US NSA name, which was Niagara Files. It was part of the 2014 NSA technology transfer, and it's a extract, transform, load system that was open sourced as part of that system. And much of the software development is now done by Cloudera for NiFi, but it is an Apache project, so it is open source and open to the world to contribute. So it understands many different data formats, many of the data formats that we've heard about already at this conference, Parquet and Kafka. It can understand some of the streams from Kafka and many different storage systems, and it can handle these natively. So it can be obviously file systems, but also S3 like object stores as well. And so NiFi, it can be run as a single machine, which is at the moment what we do, but it can also be managed through a cluster using Apache Zookeeper. And then you can also have a server-to-server connection or a client-to-server connection using a sort of a subset of NiFi, which is called MiniFi. And that is the latter is what we use. So we have a MiniFi client sitting up at the telescope, and then a NiFi server down at both Canberra and in Sydney. So it manages workflows using a GUI, which is similar to the one here, and you can kind of see the different boxes represent different processing steps in the workflow, and they're all connected. And so you can have branching, you can have them basically as complicated or as simple as you need them to be. And so we have things that basically data arrives and then just is written to disk, and then there's also processing steps where the data um, has some kind of parsing, as I mentioned before, and then might get written to a database, and then you can send an email and do all of those sorts of communications with users to let you know if things are going well or not so well. So you can move database entries as well as files, so you can have it monitor your, for example, a MongoDB. We're in a separate project. That's what we do. We actually look at a database directly and then copy collections down as required to our North Ryde site. So MongoDB, you're all very familiar with that, I'm sure. We're using a community edition because, as I said, researchers are poor, and we use it on premise. We don't use the cloud instance, mainly because we have data volumes that can get quite large. Each observation's metadata is considered as a document, and then we have a nested structure. So the FITS header that I mentioned goes in as a subdocument, and then we also have an interoperability component, so a standard way that other data centers also implement, and that goes in as another subdocument, so that people can come along and do one standard query to our data center and then to other data centers and expect to get data in the same basic format, get the results in the same format. So because I mentioned the WCS earlier, we really would like to use some of the features that MongoDB has for geospatial work. However, the WCS is far more complex. The reference system is far more complex than S2, which is what the MongoDB geospatial system is built on. And we have for some time been considering a project to add something called WCSlib as an offshore coordinate system to MongoDB, but it's a fair bit of work, and we don't have the resourcing and funding to do it as yet. But it is something that would be really cool because it would allow us to use to do a lot of the database queries, to basically say, what data have you got at this point inside some radius on the sky, and so it's spherical geometry is what we're talking about here. So the Central Authentication Service, or also known as CAS, it's managed by a software foundation called Apereo. It allows the use of multiple authentication protocols through one system. So CAS has its own protocol, but then OAuth and SAML, and you can delegate to other systems as well. It can handle multi-factor authentication. It integrates with all the big services, and it's hugely customizable, but it does work well with sort of quite minimal configuration. So you can do some quite powerful things with basic configuration in it, and it can hook in obviously with things like LDAP as well, which is how we use it. Ours connects to an Active Directory data store. So the web technologies, basically what we are trying to do is handle the queries from astronomers, for anything that's publicly available. They come along and say, I'm interested in this object at this position in the sky, or maybe data that was taken on a particular night, and then then we do authentication with CAS and also between the React and Django systems with just JSON web tokens. And as I mentioned, the data can be proprietary. So data reduction is really the processing step. That's where we take these quite large images and literally reduce them to a smaller scale. We're using Celery inside a Docker container, and this system spawns new containers using DockerPy. We chose that as an orchestration system because it was easier to get going for us than something like Kubernetes, where, as I said, we're doing all of this on premise. The containers run legacy software, which is known as 2D FDR. Which means 2-degree field. That's the size of the field of view of the telescope, which is quite a large patch of sky. It's half a degree across is the moon, so 2 degrees is the full moon rather is, so 2 degrees is very large, and data reduction, 2-degree field data reduction, and it's legacy software, so it's written in Fortran 95, and this is causing us problems. This is one of the reasons to containerize it, because if astronomers want to run this, it's getting harder to compile. It's still possible, but astronomers mainly use Macs, and so that's quite a difficult thing to support all the different versions of Macs and their different ways of handling some of these libraries. And by using containers, we can parallelize this data. So we're processing just on a single dual CPU server 120 gigabytes of data in around about 45 minutes. Now, if you had a large cluster with multiple nodes, then you would probably be able to do this even faster. But this is an improvement over what most astronomers do, which is use their laptop. And so this is something that we're just implementing at the moment, but it's going to go live into production in the coming months. So this is actually the data. This is what you get. On the left is the raw data image. It really is a 2000 by 4000 pixel image, and the sort of the various lines, the curved lines that you see there, primarily, in fact, are due to the atmosphere. They cause some of those curved lines going from left to right, and going from top to bottom are the individual spectra. So the observations are taken using a robot that can observe 400 objects at once and gets a spectrum and passes it through the spectrograph. Basically, as I said, the rainbow fingerprints, and then you end up on the left. This is just a single sort of slice from the top to bottom of the raw spectrum. This is the reduced spectrum. So as you can see, it's a lot smaller. It's been calibrated for wavelength. So for those of you not familiar with wavelength scales, you can run from 4,000 angstroms there, that's blue, very, very blue light. Still, you can see it with your eyes, and right out to 8,600 angstroms, which is just beyond the capability of your eyes, into the realm of cat vision. So what we have here, that just to give you a little bit of context of what we're trying to do here, is understand, for these things that go bang, how far away they are, what the galaxy that they're in, because we haven't had a supernova in our galaxy for hundreds of years. How far away they are, and that gives us an idea of when this might have occurred, and then some of the properties of the galaxy that the supernova is in, and then in many cases you'll try and work out properties of the star that exploded, or the objects that merged to create to form the black hole. So this is what we're trying to do. And so this number here is the Z, is known as the redshift, and it's basically it's sort of related to the galaxies as they're moving away from us. The universe, as you may know, is expanding, and so redshift you can consider as a proxy for distance. So how far away the object is. The higher the redshift, it can go up to well, I think the highest recorded redshift is around about 8 or so, 8 or 9, something like that, and that's also therefore very, very far away. But because of the speed of light, it's a proxy for time as well. So if the higher the redshift, the longer ago the event happened, and also then the closer to the beginning of the universe that the event happened. So some future challenges. We're working with the European Southern Observatory, their very large telescope and eventually their extremely large telescope. Astronomers don't have very good imaginations when it comes to naming things. But the Very Large Telescope is what you see in the image in the background. You can see the top at the top there. That is sort of the top of the telescope, and the mirror itself. This is an 8-meter mirror at the Very Large Telescope. Is at the bottom, and the huge mess of the spaghetti mess of cables and tubes. There is an instrument where you have called Muse. I can't remember what that stands for. It's another terrible astronomical acronym. But there are 24 16 megapixel cameras, so that's 4,000 by 4,000 on a square, and they have continuous flow cooling. So that's what some of those tubes are. So they're cooled with liquid nitrogen down to minus 100 and minus 80 degrees, something like that. And this means that the background noise is very, very reduced, very low. So it gives you around about 1.5 gigabytes per exposure, and every science frame that is acquired needs multiple calibrations because for the sensitivity that people are trying to reach here, you need to really make sure you get rid of all of that background noise, that bias, sort of staticky kind of granular noise that I was talking about before. And then the challenge is to move the data off Cerro Paranal, which is in the north of Chile, in the middle of the Atacama Desert, down to Santiago, and then to Munich, which is where the European Southern Observatory's main headquarters is, and also to Sydney. And we have a project where we're trying to do that. And then the data reduction itself requires quite a lot of memory, 256 gigabytes at least, and many cores in order to process this large volume of data. So that's something that we're working on right now. It's coming to a head where we need to really improve some of the workflows there. Then beyond that, in the next few years, next 2 or 3 years, is the Vera Rubin Observatory. That will come along in a slightly different place in the Atacama Desert in Chile. Chile is a very dry place. In many places in the Atacama Desert, they have never recorded rainfall in 400 years. So Cerro Pachon is the location for the Vera Rubin Observatory. It's also an 8-meter telescope, but it has a very, very large field of view. So it's able to observe the whole southern sky every 3 nights in 6 colors, sort of filters. And it's also liquid nitrogen cooled, but it's a 3.2 gigapixel camera. So it's acquiring 30 terabytes per night. And it will conduct a 10-year survey. So the data reduction on the fly is once again required for transient phenomena. So this is one of the challenges. Most of the data reduction will probably take place in the United States at the NCSA, the National Computing, and I can't even remember what that stands for, but it's the big supercomputing facility in the US, the government funded one. So it's a 10-year survey, and we'll have, once again, we're just hitting the exabyte scale. And this is process data, half an exabyte of process data. So the raw data will be even larger. So that's what happens when you observe the whole southern sky every 3 nights in 6 colors. So there's a dedicated fiber from Chile to the US, and that was with the help, piggybacked, I think, on a Google Fiber run there. So this project is partially funded by the Department of Energy in the United States. So that's where they got some of the funding and help with Google there. And a subset of this data will come to Australia. We're still in the process of working it out, but this project will probably start next year. And then beyond that, towards the end of this decade and into the next, we have the Square Kilometre Array. So there's actually 2 sites. One is in South Africa, and one is in Murchison Shire in Western Australia. You can see it there on the map. The population density is very, very low, so it's very, very radio quiet. It's also very dark, but that's for radio telescopes. That's not so important. So they have an 800-kilometre fibre, which takes the data from the current sort of Pathfinder telescopes. There's the Murchison Wide Field Array that I mentioned, and something called the Australian SKA Pathfinder, or ASCAP, They're both at the Murchison site at the moment, and they currently have a 200 gigabit per second fiber connection from Murchison down to Pawsey Supercomputer Centre in Perth. And so for now, I don't think they're doing the data processing on site, but when they build the full SKA, they will need to do the processing in situ and in Perth. And in fact, I think there's probably going to be a dedicated supercomputing center that sits alongside Pawsey. Pawsey is a national facility, so it's used by researchers in all sorts of different fields and disciplines. So thank you very much. You can follow me on Twitter at Dr. Simo. And of course, this work is not the work of mine alone. There's large contributions from the people here listed below. So thank you very much.
Awesome. Thank you, Simon, for that insightful talk. I think you mentioned a lot of domain-related concepts about how telescope, the use cases, as well as the data-related concepts. I think I personally felt it was quite insightful.
Yeah. How good was that, Simon? It was really, really good. Really interesting.
Oh, thanks.
Now,
Yeah, it's lots of fun. That's the great thing.
yeah,
Yes.
just a person starting off with a personal question. What exactly got you into astrophysics and the data side of it, data management?
The data management, I guess, to start out with astrophysics first. So that was around about 25 years ago, a bit more now. They discovered the first planet orbiting another star, and I had just started aerospace engineering at university, and that just captured my imagination. And I wrote a review paper on it as part of a physics course, and then I sort of thought, oh well, maybe I'll just go and do a little bit of astrophysics on the side, and then never really got back to the aerospace engineering. And then, so I was a research astronomer for about 15 years until about 2013. And basically, there was just an opportunity. Research has its pressures that I wasn't particularly keen on. You have to publish a lot of papers. The pressure is high. It's very, very competitive. It's hard to get jobs. There aren't many jobs out there. As I said, research doesn't have a lot of funding. And so there was an opportunity at the observatory to start looking at the data management and the web development around that. And I had some of the skills already. Astronomers have a lot of data sort of wrangling skills as just part of their day-to-day work. And so it was a good opportunity to move over. And then we realized that we needed to actually have a dedicated project. And that's when Data Central started. And we got a pot of money as part of our position in the Department of Industry at that stage, and then it sort of took off from there. And nowadays we're hosting many hundreds of, well, a couple of hundred terabytes worth of data at the moment, with more streaming in all the time.
Wow, that's really interesting. So the system that you did mention, how important, or how was your experience with respect to fault tolerance and performance? Now that you mentioned that big, because there was some data processing to be done right at the place, and also the transport layer.
Yeah, I mean, fault tolerance is we have to know, the software has to know first of all that the data is properly transferred down. So at the moment we don't have an automated system to do those checks. Those checks are done manually. Basically, I get an email saying that this many files were transferred, and then I know if that's right or not. But we are looking to that sort of, some of the more automation of those things are down the line. We also, for the processing stages, this is something that is still research based. So a lot of the reductions might be done multiple times. So you can have an automated reduction, and that might be good, but then you may still need to go back and do a manual reduction. If you find something that's really, really interesting, you think, oh wow, this will change science, this will change our understanding of the universe, then it's definitely a good idea to go and do it by hand, to make sure that the automated pipeline didn't add something that wasn't really there. Because, I mean, these data are affected by cosmic rays from
Okay.
space. So high energy particles come and hit the detector, and you get like an extra little streak. You might get an extra spike in your spectrum that you weren't expected, and that can change how the data is processed. So you've got to be really, really careful if you want to get that Time magazine front cover.
Yeah, thank you, Simon. We have a question from the audience. Claudia is
Mm-hmm.
asking, insightful, thank you. Could you please share some tips to get into that realm? To somebody with zero knowledge of astronomical concepts, but with tech knowledge and keen to get astronomical skills.
That is an awesome question. I mean, basically, there are going to be a lot of jobs in this realm in the coming years. The square kilometer array, in particular, is going to require a lot of excellent data engineers. I would say, really understand. Just try and do a bit of reading. There are some good courses through Coursera, and Swinburne University actually has a good online course, and they're often free. Not all of them, but free, just to get an idea of some of the concepts. Because then when you come along to interview, you can sort of say, oh, yes, no, I understand what the SKA is, what they're trying to do, what the science is, the origins of the universe, and looking at planets and that kind of thing. So just that really sort of, you don't have to understand, how stars form or what makes up a galaxy to a lot of detail, but just sort of some of those high level concepts. And then when the roles come up, you're well placed because you've got the data experience to be able to say, oh, look, I've got this sort of background. I'm not just keen, but I've followed up and learned some of the concepts.
Yeah, interesting. We also have another question from Simon. Wait, has there been any consideration of public cloud for services, or is it cost management that's an issue for adoption?
Cost management is a real issue. It's actually within the broader astronomical data community. It's an ongoing conversation. There are some facilities that use AWS, for example. I think it's the Space Telescope Science Institute, which runs is NASA and European Space Agency sort of funded. They provide the data management for the Hubble Space Telescope and the next generation of space telescopes. They use some AWS for their systems, but their data volumes are actually quite small. For the so for small systems, yes, I think it can work. But for the larger volumes, we really do need that dedicated presence, data arrays. I mean, as it is with the square kilometer array, they are talking about having multiple regional centers. So it'll be cloud-like, but not quite. So they'll be distributed across the world.
Yeah.
Okay.
Uh, we have one more question. Great talk. Thank you, Simon. Do you use GPU and deep learning for image processing? From Joffus Maboy.
There's a growing movement. So we actually have there's an astronomical data analysis and software services conferences coming up at the end of this month, and there'll be a whole section on machine learning and deep learning in that talk. There is some in radio data. There is a lot of work being done in GPUs. They're really trying to optimize things, so you go to quite a fundamental level with the GPU management and processing. So there is some, and certainly the new supercomputers at NCI's Gardi and the next generation one at Pawsey has some very large number of 300 plus GPUs attached to it. And so there is a growing movement there, and the machine learning definitely, because with this huge volume of data, 30 years ago you could have PhD students looking at it. There's just too much now. You need to have the machine learning to be able to even get close to processing it, and that's when you need to say at what level, when does a human get involved and look at the data, and so that's sort of where we are at the moment.
Amazing. Thank you very much, Simon, for your time.
My pleasure.
For our audience, if you want to keep engaging with Simon, you can find him on Slack. Thank you again,
Yep.
and great talk.
Great. Thank
Next,
you.
thank you.
Yeah, thank you,
Next,
Simon.
we're gonna welcome Jessica Latlin. She is joining us from New York. She's a software engineer at Materialize, passionate about crafting the perfect data architecture for every problem, and has experience building infrastructure for data science teams, Airflow, and GCP. Jessica is going to be talking about GON streaming, DBT, and Materialize.
Hey everyone, my name is Jessica Laughlin and I am a software engineer at Materialize. Today I'm going to be presenting GON streaming, DBT, and Materialize. So a little bit about me. I have worked at Goldman Sachs, Bluecore, which is a marketing tech startup in New York, and I currently work at Materialize. If my name is even vaguely familiar, I wrote a bit about Airflow when I was working as a software engineer / infrastructure engineer for the data science team at Bluecore. But I'm currently building the world's first SQL streaming database at Materialize. I've worked at Materialize for a bit over 2 years now and have worked on a lot of aspects of Materialize, but I've focused a lot on external integrations. So how we get data in, how we send data out, and how we interact with the ecosystem of data products that exist in the database space. So that being said, I've spent some time with things like Postgres, Kinesis, Kafka, but I'm really excited to talk today about how DBT and Materialize can work together to transform your streaming data in real time. So the first chunk of this talk, I'm going to talk a little bit about DBT, but I'm primarily going to try to convince you that DBT cannot transform streaming data efficiently in real time. And I'm going to follow that up by a chunk about Materialize, where I will, again, try to convince you that using Materialize is the only way to transform streaming data efficiently in real time with DBT. I'm going to be walking through some samples and demos and smaller problems as we go through this talk, but at the end, I will work my way through a full-fledged demo that will be available on the Materialize GitHub repo. So if you are Materialize curious, please feel free to check that out after the talk. Reach out to us on Slack, open issues. Love to chat about it. Without further ado, let's get started. So let's start off by talking about DBT. DBT stands for Data Build Tool, and the goal of DBT is to completely take over the T, or transformation step, in your traditional ETL, extract, transform, load pipeline. To understand how it would do that, let's take a closer look at how DBT actually works. DBT performs transformations of your data directly in your data warehouse using DBT models. So let's say you have some sort of data warehouse that has data in it. DBT supports connections to lots of different types of data warehouses. So this might be MySQL or Postgres or BigQuery or Snowflake, or as we'll talk about later, it could be Materialize. And historically, if you wanted to transform data in your data warehouse, you might write your own SQL to do it. You might have to pipe data between data warehouses, or you might have to pull chunks of data into memory to perform computations and then spit it back into your data warehouse. But using DBT, all you need to do is define a DBT project that connects to that data warehouse and define the transformations that you want to perform in your DBT model files. We're going to talk a bit more about model files in a minute, but all you need to know for now is that DBT will transform your data each time you execute DBT run. Each time you execute DBT run, each of your models defined in your models directory will be executed. This means that the SQL statements within the models will be executed against the existing data in your data warehouse, outputting some transformed data that will still be contained in the same data warehouse. At this point, it might be obvious that DBT models are doing most of the work in DBT transforming your data inside of your data warehouse. The good news is that DBT models are pretty simple to create. They only have two components. The first component is that a DBT model is a SQL statement that expresses your desired data transformation. The second component of a DBT model is a materialization parameter that determines how your transformed data is persisted in the underlying data warehouse. That might feel a bit abstract, so let's make it more concrete. Imagine that we had this stock price table in our data warehouse. The stock is simply a text field of the ticker stock symbol, and the price is the price of a stock at a given point in time. This table on its own isn't super interesting. What you'd likely want to do is perform some sort of calculation, aggregation, or maybe even something predictive on this table. For our example though, let's imagine that we just wanted to know what's the average price per stock. Luckily, we can easily define that using a DBT model. On the right-hand side is our select statement defining our DBT model. So we want to select stock and average price from stock prices, and then group that by the stock. This is the first half of the definition of our model, and all we have left is to determine the materialization parameter of this model. DBT supports 4 types of materializations out of the box. So as I've mentioned a few times, the materialization determines how the transformation is persisted. So the 4 built-in options are view, table, incremental, and ephemeral. When you DBT run a model with any of these materialization types, you are persisting your transformed data as a view, a table with refreshes, which looks a little bit like a traditional materialized view, or a CTE, which is a common table expression. The good news is that any of these data types that are stored and persisted in your database are great at transforming batch data. The bad news is that none of them are sufficient to transform streaming data in real time. To understand why, let's revisit our stock price table from before. So this is the same stock price table that we saw, and here is the transformation that we performed using our DBT model. So we have the average price per ticker stock symbol. Now, my question is, what happens when new data arrives in the underlying stock price table? What do you expect to be returned to the user if they are looking for the average stock price of Amazon? That depends on the materialization type that was chosen for the model. Each time a model with a view or an ephemeral materialization is queried, the data will be retransformed. So the user will get the up-to-date result, meaning the correct average price for the Amazon stock, but you are paying some cost in terms of computation and in terms of time each time it's queried and each time it needs to be updated. On the other hand, models that use a table or an incremental materialization will simply return stale data. In order to include that new row of data in your transformed model, you're going to need to DBT run that model again. So I claimed earlier that these existing DBT materialization types are sufficient to transform batch data, but insufficient to transform streaming data. To make sure that we're all on the same page, let's just go over what batch data is versus what streaming data is. Batch data is data that arrives in discrete batches. That could be once a minute, once an hour, once a day. The interval doesn't matter. All that matters is that there is no new data that arrives between batches. Streaming data, on the other hand, arrives continually and at no particular schedule. So there's no way of knowing when you will receive the next row or bit of data, or how long it will be until then. So now that we've clarified what I mean by batch and streaming data, You might be wondering why I said DBT and its existing materializations are sufficient to transform batch data while they are insufficient to transform streaming data. To understand, let's step back to our stock price example. Here we have our stock price table on the left, and on the right we have our transform table that was created via DBT run. If we have batches of data arriving in our stock price table on the left, and we are certain that we will not be getting new rows in between the batches of data, that means that we can reliably and efficiently schedule or trigger DBT runs to retransform that data in between batches. This means that view and ephemeral models will still perform the same transformations and they'll still have the same costs, but table and incremental models will never return stale data. So we are able to efficiently transform batch data using DBT by scheduling DBT run between batches. Unfortunately, we're unable to do the same thing with streaming data. By definition, streaming data arrives continually and at no particular schedule. So there's no point at which we could execute, schedule, or trigger a DBT run to keep models up to date. This is why I said at the beginning that DBT and its current materialization types are insufficient to transform data efficiently in real time. So what can you do if you have streaming data, but you want to transform it with DBT? There are two ways that DBT has suggested working around the issue. I talk about this a bit in a blog post that I'm happy to link later, but for all intents and purposes, using Materialize with DBT is the only way to transform your streaming data in real time. So this seems like a good jumping off point. Let's move on over to Materialize. I feel like a lot of y'all might have been familiar with DBT. This might be your first introduction to Materialize, so welcome. Materialize is the first true SQL streaming database. It's built on top of differential data flow and timely data flow, which were led by Frank McSherry, who is a co-founder of Materialize, if you are familiar. Materialize itself is wire compatible with Postgres, and it will return correct answers to your queries in milliseconds. So at a pretty high level, this is how Materialize works. There is the Postgres SQL compatible interface, so you interact with Materialize via SQL statements, and we turn your SQL statements into differential and timely data flows. We ingest different types of streaming data, so Postgres bin logs, we ingest data from Kafka, Kinesis, from files from S3, that's the newest source, and you can read data from Materialize in a few different ways. You can query Materialize interactively, once again using Postgres SQL. You can power real-time dashboards, or you can send data back out to streaming systems such as Kafka. We will be supporting more types of syncs in the future. So now that we've taken a high-level look at what Materialize is, you might be wondering how Materialize enables DBT to transform streaming data in real time. And the answer is we use Materialize's superpower, incremental materialized views. These are materialized views that never go out of date and never do any more work than necessary. We are able to maintain incremental materialized views by backing the data that's stored in Materialize with differential and timely data flows, which I mentioned in the last slide. To see what this looks like in practice, let's step back to our example. So we're back to our stock price table, but imagine that we have a new row of data flow in. And after that, there might be another new row of data. As this is a stock price table, you can imagine that new prices would be flowing in every second, every minute, every hour. If we were creating a model on top of this table and we used a view or ephemeral model, which as you might remember are backed by views and CTEs, the model would recompute the average price each time the user queried your model. If you are using a table or incremental model, which are both backed by tables, your model would return stale data until you DBT ran it again. However, if you are using an incremental materialized view with materialize, your model would return the correct answer without having to recompute or DBT run your model again. So how do incremental materialized views work? As the name suggests, incremental materialized views maintain correct results incrementally. So instead of having to recompute the average value each time, or instead of returning stale data, materialize maintains an incremental average of each stock price. In materialize, this looks like a running sum of the prices divided by a running count. So when our first additional Amazon stock flows in, this looks like summing the two stock values, which would give us 6,755, and dividing that by the running count, which would be 2, outputting an average value of 3,377. As our third Amazon row flows in, you'll notice that we do not redo any work. We use the running sum that we generated from the previous row, so 6,755. We sum that with the new price of Amazon, 3,378, and we divide that by the new running count, which is 3. So for the sum, we get 10,000, and then for our new updated running count, we get 3,378. So to recap, incremental materialized views maintain up-to-date results of your queries without needing to be DBT run. They only perform work when necessary, so we didn't have to recompute the average from scratch. And because we are maintaining the result incrementally, we are able to return correct results within milliseconds. So I've said this a few times during this talk, but just to be super clear, as new data flows into your streaming source, your model will only be able to return correct results without recomputing if you use Materialize's materialized view materialization for your DBT models. It will not be able to do this with a view or ephemeral materialization, and it will not be able to do this with table or incremental materializations. So for this reason, DBT and materialize together are the only way to transform your streaming data efficiently in real time. In case you missed it, there is another incredible bonus of using DBT and materialize together to transform your streaming data, and that is that you will be able to DBT run your models once and never again. Models backed by materializes incremental materialized views always have up-to-date results to your queries. They never have stale data, they never recompute your data, and so you never have to worry about scheduling DBT runs or triggering DBT runs. Anytime you query a model backed by a materialized view, your results will be up to date. So at this point, I hope you are excited about DBT and materialize and transforming your streaming data in real time. So let's take a look at what it would actually look like to work with some stock data and with DBT and materialize together. As a reminder, this project is available in the Materialize GitHub repo, so please feel free to check it out on your own. So now that we've talked a lot about DBT and Materialize, let's walk through a demo project together. If you go to Materialize repository, under the Play directory, you can find a project called Materialize Cloud DBT. And this is just a small DBT project that lets you connect to the cloud offering of Materialize. So I have this project open in my Visual Studio Code, so let's walk through it together. For those of you who don't know, this is a dbt project.yaml file, which is the highest level config file for a dbt project. It gives us some useful information like the name of the project, the profile of the project. So dbt profiles are what tell dbt which dbt adapter to use. So for those of you who aren't familiar, a dbt adapter is the piece of code that connects dbt to a data warehouse. So we have a DBT materialize adapter, and that's what you'd need to use to connect DBT to materialize. It's the same thing that you'd use for other databases like BigQuery or Snowflake. This is just the materialize specific one. And you can see that I'm using a profile called Test Cloud. This is just a set of information that allows DBT to connect to a materialized cloud instance. So here's a sample of that type of profile. You can see that the type here is materialized. That tells DBT to use the DBT materialize adapter. I have some cloud host information and other authentication information that allows DBT to actually connect to my cloud instance. And then here you can see that our source path is just the models directory, which is open on the left. And models, as you may remember, are where we actually perform transformations of the data in our materialized data warehouse. So let's take a look at our models together. The first model that we're going to care about is called Market Orders Raw, and it's what creates a materialized source in Materialize. Sources in Materialize are how you ingest data from other streaming systems or databases or even flat files into Materialize in order to transform that data. In this instance, we're ingesting data from PubNub, which is a publish-subscribe service. They also have some free data streams, so that's what we're reading in this demo. We're reading from their PubNub Market Orders data stream. But the PubNub Market Orders data stream, called Market Orders Raw, only comes in as text. So we are going to create a market orders model that breaks that text into useful fields. So the first field is symbol, which is just the ticker stock symbol as text. And the second field is bid price, which is the price of the stock cast as a float. Once we have this market orders model available, we're going to be able to use that to create the running average that we saw in our previous slides. So this is the select symbol and average bid price from the market orders model and group that by symbol. You may have noticed that all of these models this model and the market orders model both are materialized view materializations. So this is in contrast to the view, CTE, incremental, or ephemeral models that we've talked about. This is what tells DBT and the DBT materialize adapter to create an incremental materialized view in Materialize. So now that we know what our models look like, let's run them. So I'm in my iTerm, I have the Materialized Cloud DBT project locally, and I'm in that directory. The first thing I'm going to do is create a virtual environment. And then once I have that virtual environment, I am going to pip install DBT Materialize. So this installs the DBT Materialize adapter. It also installs anything you need from DBT, so you don't need to install both. It's actually a bit lighter just to install the DBT Materialize adapter. Now, once that's installed, we can just check that our test cloud profile and our DBT Materialize adapter can connect to my cloud instance. Ta-da! It can. That's great news. So now that we know we can connect, let's actually DBT run our models. As you may have remembered from earlier in the talk, I said that when you use the Materialize view materialization, you can DBT run your models once and never again. So this was our single DBT run. And with our DBT run, we created the source, the thing that brings data into Materialize. We parsed that source into useful columns. We created an index, which is an exercise left to the reader, and we created our market orders average view, so the view we've been working with for the entirety of this talk. So now that our models have been run, let's take a look at that data changing in real time in my Materialize Cloud instance. In order to see our data change in real time, I'm just going to use this watch command, which every second will output select star from market orders average. Ta-da! This is it. This is the magic. We are not recomputing these averages each time a new row of data flows in from PubNub. We are not having to DBT run this model again. As you may remember, I ran this model once. I am never running it again. But by backing my model with Materialize's materialized view, I am able to maintain these averages incrementally. So each time my watch command queries Materialize, I am getting the up-to-date average without doing any more work than necessary. So to bring it on home, using DBT with Materialize is the only way to transform your streaming data in real time. I hope you enjoyed this talk. I hope you try it out at home. And please feel free to reach out on GitHub or Slack because we are really excited to get you all transforming your streaming data with DBT and Materialize. Thank you.
Hello, Jessica.
Hi, thanks for having me. I like your transitions, they're great.
Yeah. Are you joining from New York?
I'm joining from Los Angeles. I'm usually in New York with Materialize, but I've taken some time to be in the usual sunshine, cloudy today.
Perfect. Thank you for joining us. It was a great session. Sorry, I interrupted you, that Aditya.
No, I was just about to say thank you so much for that insightful talk. Just going over to the question, we have a question from YouTube that Ravi K was asking about the materialized cloud and whether it can be hosted inside a company VPC.
Yeah, so Materialize Cloud is in open beta right now. It's actually hosted by Materialize in AWS EC2 instances. If you needed to figure something else out, we maybe could get creative with that. Our cloud folks are figuring out exactly what our cloud offering entails at the moment. It's pretty new as of, I think, a month ago, which is exciting news for us.
Yeah,
Perfect.
yeah.
And Jessica, if anyone wants to start with Materialize, whether they have had experience with DBT or not, what would be your recommendations?
Yeah, I would say we have a few example demo projects in our Materialize GitHub repository. So Materialize is source available. All of our code is available on GitHub. There is the repository, which I showed off, and there are a few sample DBT projects there. So if you just want to try out the tool itself, I would recommend that. And then joining our Slack, we are happy to help out for any transition with a real project.
Excellent.
What are some use cases that you're seeing right now from your users at Materialize?
Yeah, one of the popular use cases, which people would probably guess, are banking. So any type of tracking of financial trades. Another popular use case that is coming up a lot is real-time billing. So per second, per minute, per hour billing for folks. And then the last group of use cases that seem to be really popular are for marketing tech use cases. So things like abandoned cart, to send that off in minutes instead of hours, which you would have to do with batch.
Yeah, awesome. Sounds interesting. I think the next question we have from Stephen Joseph, is it partition tolerant, like from the CAP theorem?
Yeah, we are currently working on that. So we have a team building out our persistence layer. And those folks are, right now, everything runs either on a binary or on cloud. And we don't persist anything that's in progress. Everything's persisted in local memory at the moment. But that should be coming out within the next month or two. And hopefully we should be able to uphold that promise.
Nice, interesting
Great.
stuff coming on the roadmap.
And and we have Simon Rumble asking, any volume limits on this if I were talking big media company stuff?
That's a really good question. It's been a while since I've looked at our limits, but we can handle tens of thousands of updates a second. I think that's the last limit that I saw with one of the financial firms that we were working with.
Yeah, awesome. I might squeeze in one last question from Ravi again. How does it handle SCD type 2 dimensions?
That's a really good question that I will have to ask in our Slack. I haven't thought about that. But Ravi, if you want to join our Slack, we're super active in it. You can ask it and I will ping the right person for you.
Awesome. Thank you so much for joining, Jessica.
Yeah, thank
Jessica,
you.
a quick question. If anyone wants to see the roadmap of Materialize, is there a place where they can go?
Yeah, we have regular blog posts that come out with our releases that mention recent features and also some things that folks can look out for. We also mention that occasionally in our Slack, some sneak peeks.
Perfect. Thank you very much for joining us again.
Yeah.
Great talk.
Thank you so
Thank you very
much.
much.
Thank you.
Thank you. I think it's time for a break. Is that correct, Aditya?
Yep, I think we should give our audience a
We're-
quick break.
We're going to have a 10-minute coffee break. Yes.
Yes, please, so audience, please do go and refresh, grab some snacks, and tune in again at 11:40, where we'll be having our next session.
Thank you. See you soon.
See you. right. Welcome back, everyone. And we are currently in the morning session of the day 3 of the Data Engineering Conference. And next up, we have Stephen Weingartner. Stephen Weingartner is from Snowflake. He's held multiple analytic roles since 1990s. Prior to that, he was also an analytics expert at Oracle. And he's here today to talk about a single data platform for all of your workloads. So without waiting further, let's hand it over to Stephen.
Hello everyone, my name is Stephen Weingartner, and today I'm going to be covering the topic of a single data platform for all your workloads. Just a brief bio about myself. I've been at Snowflake for only a few months, five or so months. My title is a Senior Solution Engineer, and I've worked in the analytics space since the 1990s, so been around the block a couple times. Basically, this is the challenge a lot of organizations face. Basically, when they're trying to deliver data solutions, they're dealing with all sorts of complexity. There's so many different programming languages. Data can be very fragmented. You can have HR doing their own thing, finance doing their own thing, data scientists, data engineers doing their own thing. It can be difficult to transfer data between organizations. Even sharing within an organization can be difficult. Organizations, they get frustrated when it takes a while to deliver even reports, but certainly even machine learning AI can take a very long time to deliver. And lastly, organizations have headaches around heavy costs, inability to scale up, scale down, poor performance as well, which distracts the team, and they struggle with those issues. So recently on Reddit, there's a sub for data engineers, and someone came up with a little list of things for data engineers to learn in order to be pretty proficient at their job. And I just want to bring it up to show that this is a challenge, and this is why a lot of organizations really struggle to find someone who is a quote-unquote really good data engineer, because it's just a massive range of skills. There's a whole bunch of tech. What we're seeing here is can be quite overwhelming for a lot of people to get into, and ultimately they're doing all this to try to get to the very tail end, which is where you can get your report in a tool like Tableau or Power BI, or for the data scientist to be able to build a prediction using some sort of tool to build a model. As some more background, as some challenges around data. So here's a typical way that organizations have been building data platforms for quite a while. You basically build your ETLs, you have a data warehouse, you have some sort of reporting tool, and then you're done. And what's happened with time is it's gotten a bit more complex. We have like cloud solutions, people have incorporated data lakes, you have CDC or streaming data, Spark to crunch big numbers. Within the organization, you get more data sources, so IoT data, AI, ML. You get different parts of the business, like the finance team went off and bought their own data warehouse, or HR has their own data mart. Multiple data scientists have multiple solutions. You could have different data engineers using different data lakes rather than a single data lake. And with time, it just gets more and more complex. You get integrations over the place, people going over the place to get data, people in the business having to mess around getting data from one place to the other or manipulate themselves. So this is a problem that a lot of organizations face today, or at least they have an architecture where this is where they're going. And as a result, what happens is you kind of get everyone in a situation where they're not really working together. The data engineers have their own platform. The data scientists, they're doing their own things with the data lake and their own file formats and their own feeds of data. The BI team has some clean data in the data warehouse, but it's not everything, and they struggle to work together. So this is where Snowflake comes in. It's on the left-hand side, the same data sources, and on the right-hand side, all the same different ways to consume the data. And what Snowflake is a single platform that can run on all three clouds. I'm based in Australia. Within Australia, we run on either AWS or Azure. And the key thing is we can handle all these different workloads. We've been around for 9 years, so many people know of us as this data warehouse. We came out as this super high-speed data warehouse that was just so fast and so easy. It was really easy to migrate to that and whip out your reports and speed up your data warehouse and lower your costs. And quickly after that, people realized that our disk is so cheap, you can just stick in all the data you want. We have structures that can handle semi-structured data, so like JSON files, XML, Parquet files, and such. And therefore, Snowflake can also act as your data lake. And from there, you can also do your data engineering instead of the identical platform, and data scientists join in and ease the shared data as well. The philosophies around Snowflake are that it's a single platform to handle all those workloads. It is a SaaS type of a solution. You don't need DBAs to do run maintain. No one's applying any patches within your organization or up at 2 in the morning fixing problems. And we have a ton of security and governance features, and this applies to all of your data, really crucially important. And lastly, as I spoke before, we came out with this unlimited sort of way to performance and scale, and it applies across all these workloads, not just the data warehousing, but it applies to the data lake and data science and onwards. So I'll just kind of show one slide of the architecture of how it kind of hangs together. In the center, we have our what we call databases, which are kind of like our file type of system. It's totally separated out from our next ring out, which is compute. And basically, if you give us like a big file, what we do is we break it up in tiny little, what we call micro partitions, tiny little files that we store on the object storage of these cloud vendors, so AWS S3 or Azure Blob Storage. In that middle ring, spin up, spin down, turn on, turn off. It's all automated. They start and stop within a second. Basically, we're running all this compute on the VMs of the cloud provider. So, our warehouse is, basically an EC2 sort of instance that's always running hot, and it's just provided whenever you need it. Or when running on Azure, it'd be Azure VMs. And because this turns on, turns off pretty instantaneously, what we can do is just normally leave everything turned off, that you're only leveraging compute only when you need it, and when you're done, you give the compute back again, and you stop paying. The final outer layer is our cloud kind of SaaS sort of services type of layer, and this is where when you want to understand your table structures, create tables, play with your roles and security, connect to an API or whatever, then you leverage that layer. So I'm going to cover just briefly today how Snowflake works for several of these key use cases. Basically, for the data lake, I have a lot of information on this slide. Don't want to cover it all, but there's a couple of key points I'd like to get to. Is that on the left-hand side, we're able to bring in data, all sorts of different data. You can use Snowpipe to automatically suck in data from an existing data lake. So if you've already figured out how to land data into AWS S3 or Azure storage, you can just use that to automatically suck the data into Snowflake. We have Kafka connectors where you can stream in real-time type of data, IoT type of data. On the lower left, I think is one of the more interesting ones, is we have support for semi-structured data. So you can just load in your JSON files just as they are. You don't have to parse them out, just load them in. And we have a SQL type of language that you'd be able to create views with, and basically your BI users are immediately able to use those JSON sort of files and query against it at a really high speed. The data basically appears like a table. I'm not going to go through all the points here, but basically, we could spend a whole time just on the topic of the features of Snowflake that make it work as a data lake. Interesting enough, if you look at Gartner Peer Insights, Snowflake is extremely favored by users as being just a really easy place to be your data lake. In addition to being kind of low cost for disk and easy to interact, because you can just use SQL to interact with all your data, it has just a whole bunch of capabilities that allow it to work together within the bigger picture. And I think one of the key things, I think that actually the most important thing about Snowflake when it comes to the uses the data lake is at the very bottom where it's secured and governed access to all data. We have a whole bunch of security and governance controls as to how people will access this data. And this is something that doesn't exist with a lot of other tools. Okay, so how do we use Snowflake for data engineering? I'm a big fan of just keeping everything as simple as possible whenever possible, and cutting out risk and time and challenges and headaches. So, in contrast to learning every single language and actually using every single language when you want to move a piece of data from one place to the other, I personally have a view of when you can use something simple. So here's a screen snapshot of using Fivetran, and it's just kind of where you type in the username, password sort of thing for your source, if it's Salesforce or Workday or an Oracle database. Here's like a CDC sort of connection that you're going to straight load it into Snowflake. And basically what a tool like Fivetran does is they have like 170 adapters, and it just kind of near real-time synchronizes all the data from all those upstream systems straight into Snowflake. And it's just kind of an idiot-proof type of tool. Another popular tool out there that people are using as Snowflake is Matillion. And it's a fairly newer type of ETL tool. It's cloud native, and it's kind of more of a drag and drop sort of interface to build your data flows. A lot of organizations are using this to quickly build their integrations and their transformations within Snowflake. This pushes everything down. This really understands how Snowflake works, and it's able to work well within the tool at high speed. dbt is really popular. dbt is designed for people who are familiar with SQL, and it's deeply integrated with Git, and it can also churn out its own documentation. So it's kind of a lightweight, very data engineering friendly, very industrial sort of method of building and maintaining transformations inside of Snowflake. And it's also an extremely popular tool that's very often paired up with Snowflake. Interesting enough, this is also very often paired up with Fivetran. So Fivetran will land your data into Snowflake. And then there's a whole bunch of pre-built dbt jobs that you can just grab, and they will, for example, pre-build a star schema against all sorts of systems, things like Salesforce. So this is a slide that covers that, what I mentioned before around JSON type of data. So you can bring in data like JSON and just immediately start using it. You don't have to parse it out with your ETL tools, or try to figure out what every single structure within a structure is for those JSON files. It's you almost kind of have to see the demo to see how well this thing works, but it's very efficient for helping organizations take all their JSON data from all these REST APIs from all their SaaS applications and just immediately use this data in downstream. We have serverless tasks. So an example is Snowpipe, where you could just read against your files that are landing on S3. We have connectors to Kafka. We have tasks and streams within Snowflake that can process data. And basically this just means all these can just kind of run 24/7. You don't have to worry about how big it is. It'll just auto scale to whatever you need. And it just is effectively shut off or all the way scaled down to always minimize your spend, and it only has to scale up when needed. Schema detection is a pretty new feature, and this is where you can just kind of load some files in, and Snowflake will figure out what's the structure of these and then create a table with the proper columns that match up with this. We have a bit of a roadmap on this topic as well. And data engineers are also kind of keen to be able to share the data out with applications. So you can leverage SQL APIs and expose Snowflake out via a REST API, and then applications just can tap into this data via this API and effectively just pass a SQL statement and then get whatever data they need back. Snowpark is a pretty new feature of Snowflake, and what it allows organizations to do is to use the data engineers and data scientists can use their language of choice. They can use like Scala, We have Java and Python coming up quite soon, where they can code in the language of choice. And then what happens is Snowflake will translate whatever they're doing basically into SQL statements. So basically, the data engineers and data scientists can be in like a Jupyter notebook and just code in whatever language they want. And just by importing in these Snowpark type libraries, then whenever they're doing something like a data frame, like I want to use this sort of data, then Snowflake translates, send it to SQL statements for selections and also inserting data back into Snowflake. So it's an easy way for you to use your language of choice when you want to interact with Snowflake. Java UDFs are basically your ability to upload Java jar files into Snowflake and run complex calculations and algorithms inside of Snowflake. So when you want to run, for example, if you have a predictive model from data science or natural language processing, you've created a jar file that can do that. Now you can basically pump all your information within Snowflake. If you have it in a table, you can run it through those functions or procedures that are leveraging that jar file, and then creating a whole other table. So kind of sky's the limit for now what you can do within Snowflake for manipulating your data. We're no longer limited by SQL. It's kind of whatever you want to code in a way. And again, so like similar to the data lake, so data engineers would leverage a lot of these same capabilities that make Snowflake quite popular as a data lake. And I've covered a lot of these points. Data sharing is a very interesting feature for Snowflake because we're all up in the cloud. It's easy just to share data from one place to the other. And this avoids a headache that organizations have around having FTP servers, which they have to worry about the security of these, and interfaces breaking, and some supplier didn't send one of the files, and how are you going to recover that? How are you going to rebuild your messed up data? So with Snowflake, it's just basically a matter of kind of clicking that you want to share a table with another organization, and vice versa. You can get data from them. You can kind of create these exchanges where you have a couple close corporate partners or other government partners that you're working with, and only you guys are sharing data together. Or you can do this external. You can grab, we have hundreds of really interesting data sets available on our public marketplace. And even each of those data sets can have dozens or hundreds of tables that someone else maintains the data. And this is really cool. I have a machine learning demo, and I use some data that Johns Hopkins University maintains. And it was so easy. Just click the button, grab the data, and every time I run my demo, my data has been refreshed for all this coronavirus and all this Google mobility related data. Every time I do my machine learning predictions, someone else did all the hard yards to make sure my data is up to date. And so that was one example where I used this COVID-19 data right there, but there's plenty of other data available for organizations. And this visualization here is showing which organizations are kind of using which data sets and how they've connected together. We're really growing in popularity. This hasn't been around for that long, but it's growing pretty quick. So Snowflake as a solution for data science, basically we handle both sorts of data scientists, both your citizen data scientists and also your more traditional data scientists that are using their code sort of interfaces, writing a whole bunch of languages and using frameworks and libraries. So for the citizen data scientist, we're very close partners with Dataiku, DataRobot, H2O.ai. Those three citizen data science tools have heavily modified their tools so that they can run basically inside of Snowflake. Their feature engineering and a lot of what they do actually runs inside of Snowflake. You don't have to suck the data out to have it run inside of those tools. But a lot of organizations also use tools like Alteryx, SageMaker, Azure ML, and those work, fine as well. The data scientists, they're using like Jupyter, Zeppelin notebooks. All this works with Snowflake, and you can use Python and R. Basically, sky's the limit for how you can connect and interact with this data. So what this slide here is basically showing is where the workload is occurring. And basically on the left-hand side is basically the feature engineering. So when you have to clean up and modify your data to build a model, this is like 80% of where data scientists spend their time. And basically all that can be pushed and run within Snowflake. And that's quite helpful. If you have a lot of data, you can use the massive horsepower and the speed. And this is where all your data is, because it's a good data lake, it's a good data warehouse, so all your data is there anyway. And it's pretty easy to manipulate and do your feature engineering there. Currently, basically all the tools will do all the training in the tool rather than inside of Snowflake. So basically when you do the serious calculations, to all the real number crunching to produce a model, that's actually occurring within the tool. Once you have the model ready, then you have two options. You can either host that model in your tool, or in a cloud, wherever, or on premise, wherever you want to host your model. You do have an option of hosting that model within Snowflake. So using our Java UDFs, if you save your model as a Java jar file, then you can upload it into Snowflake and leverage right there. You can score a massive amount of data right through that model within Snowflake without pulling any data out, and it performs extremely efficiently. This is just a single screen snapshot of DataIQ, and as you can see, it just is an example of how one of the citizen data science sort of tools interacts with Snowflake. Is that as you move through the stages to clean up and join and manipulate your data and do your feature engineering, and then even creating models and then scoring your models into a final data set that has all your predictions applied, each of those blue boxes is a Snowflake table. So this is a pretty cool thing that for one, the performance is good, but secondly, now your data engineers can work together with your data scientists. Your data scientists are on the identical platform as your Power BI and Tableau type of developers and all your other BI sort of users. So finally, they can all really start working together. It's easy for them to share tables, within the data warehouse or data lake, and vice versa. Data scientists, easy for them to share backwards to the rest of the organization. And lastly, one of the key things I want to show is talking about governance and security. I'm not going to cover all the security options, but a lot of organizations are deeply concerned about governing data, of knowing where their private, sensitive customer or patient data is, being able to find where it is, making sure it's not in their dev environments to automatically search for that. If they find any, they want mechanisms to control who has access, and to be able to anonymize it, to apply tokens, apply masking. If there's ever any leak of any data that someone maliciously let data out, then Snowflake has all these features where on that right-hand side you can trace back and see who's run any query, what was the IP address, what was the user, the role, and such. So we have a whole bunch of governance capabilities built in to Snowflake. And the cool thing is it isn't just for the data warehouse. A lot of organizations have been doing that type of stuff for 10 plus years in their data warehouse. But because we're the single platform that works across every single use case, we don't have a big, huge gaping hole in our security and governance sort of posture where the data lake or the data science space is a total free for all, where people just kind of get all access to all data. So with that, that's basically the quick look of Snowflake. And what all this means is that we've gone from this sort of situation to a situation where each of those pain points has been improved. And look, in summary, this is just a really super quick taste. Be happy to share more information in a Q&A, or feel free to reach out if you have any other questions. Thank you.
Thank you, Stephen, and welcome.
Yeah, thanks for having me.
Are you joining us from Melbourne?
I'm based in Melbourne. I'm originally from America. I've been here for about 12 years. I haven't lost any accent, so people normally ask me which country I live in. But yeah.
Great to have you, and great session. I think that probably one of the questions I have is, if someone wants to bring Snowflake within an existing ecosystem, whether it's to integrate it with the current tools or to migrate from a previous warehouse, what would be your recommendations of how to start?
Well, look, I mean, obviously, Snowflake is always happy to talk to you and help figure this out. You don't need to figure it out all by yourself. A lot of companies have made changes. We're very open. We connect to a lot of stuff. I've seen a lot of different bits and pieces. And also sometimes a little bit phase by phase approach, rather than say, look, we're going to move every single thing, all aspects of reporting and data science and data lake all over to Snowflake. A lot of times just like a single use case. It's kind of like, you kind of know that you're not very happy with this platform. There might be another use case. Let's just get going on this little one right here. For some organizations, it's first their data warehouse. For others, they're looking holistically as a data lake and data warehouse. For some, there may be a particular use case, something like a data sharing type of use case that they need to share data with another organization. A bit of a story. I'm happy to work with people. We're always happy to work with people to kind of figure out the whole story. You know, there's a security assessment and kind of figuring out your integration tools and figuring out the actual migration of any data. So happy to advise on that. But a lot of customers have done it. I mean, the good thing is Snowflake is just a SQL database. It's surprisingly a very simple tool. Anyone that knows SQL, they can quickly learn Snowflake. So the good thing is like you can kind of quickly learn it, quickly have a play with it. If you have a team of colleagues that you're already doing stuff with data, it's pretty kind of easy to re-gear these people that they start using Snowflake.
Yeah, an interesting point that you mentioned there about data sharing, Stephen, where one organization can actually maintain the data and then share it across for others.
Yeah.
How exactly does that work?
So because we're up in the cloud, we have the architectures. All of our data is held in object storage. So when we're running on Azure, it's basically on Azure Blob Storage. When we're running Snowflake customers, we're running on AWS, it's running on S3. And so we've abstracted what is a database, what's a schema, what's a table, what's a customer. You know, under the hood, the data is, you know, in S3 or it's in Azure Blob Storage. And for Snowflake, it is very easy for us just to create this UI and this mechanism where you just say, look, here's these databases that get to see the same data. Here's these tables that get to see the same data. Here's these other customers, other accounts, other organizations that get to see the same data. And it's in a way, it's just for us under the hood, it's kind of simple. It's just repointing who gets to see it. So you don't need to move the data at all. With if you're running, for example, Snowflake on AWS, then it's just simply clicking, here's another company that I want them to see this database or this table or this view. And then you just click it, let them see it, and then they log in and then they click accept it, see it. So that's when they have their own Snowflake account. If a customer does not have their own Snowflake account, then you can just create a reader, like a read-only sort of user and framework there, and then they can just take their, you know, BI tools or whatever and just read straight from that. But happy to get more into it. We could always deeper dive exactly how it works if anyone's interested for more detail.
Yeah. I think you use some really cool visualizations there about the skills of a data engineer and how it is within a business. The
It's
memes that
tough.
you use are really hilarious.
Oh, it's tough.
Yeah, bringing the you know, all data practitioners together is a interesting challenge to solve.
It's the challenge, yeah. And I hear it a lot because, you know, a lot of customers, they see the Power BI report, like that's kind of where they're trying to go. And the next layer down, they see Snowflake and they're like, oh, cool, let's just get the data there. But the whole data engineering piece, getting the data in, manipulating it, and getting the data clean and ready to go is really the hard work, the hard yards. And so, interesting enough, I work with a lot of customers to try to help simplify that, and they're kind of looking at everything holistically, like how can we uplift every single thing. It's almost like a third generation of a data platform. You know, first everything was on-prem. You'd have an older ETL tool, like an older database. The second gen was moving to like a Redshift and having Spark and Scala and EMR and MapReduce and you name the tech. And now this third little wave is a little bit of a simplification of like, hey, let's just go back to SQL. Let's like, hey, if there's a single tool, like that Fivetran thing, like, hey, just here's the username for the source, the username for the target, and kind of push the go button. And so sometimes you can't always do that, but there's an attraction towards simplification of a lot of that, and let the data engineers work on the tougher challenges rather than just the bread and butter moving data from one place to the other.
Yeah, very well said. Yeah, I totally agree. Thank you very much, Stephen. That's very insightful. And if our audience wants to engage with you, they can find you on Slack channel.
Yeah, sure. Or finding me on LinkedIn. Happy to connect. Very good.
Awesome. Thank you.
Right.
Thank
you very much.
Yeah. Thank you. Have a good day.
You too.
Bye.
Bye. So we're gonna welcome our last speaker of the morning. So we have next Tejas Manohar. Tejas is the co-founder and CEO of at HighTouch. Previously worked at Segment, where he realized the importance of data warehouses. And he will bring us a session on putting your data warehouse to work, reverse ETL and operational analytics. He's joining us from San Francisco.
Yep.
Hey everyone, I'm Tejas, joining from San Francisco here.
Hi, welcome.
Hey, thanks for having me.
Good to have you here. So we can move and we can start your session, and where we will do later the questions.
Perfect. Cool. Well, hey, I'm Tejas from HighTouch, and today we're going to be talking about reverse ETL and how to put your warehouse to work for more than analytics. So I'm Tejas, one of the founders of HighTouch, and joining me today will also be Ash from MyMuscleChef, who manages data and insights over there. And today what we're going to be discussing is, first off, what's reverse ETL? It's a buzzword that's really picking up in the data space and data infrastructure, data engineering, data analytics, and why is it taking off? What does it really do? Then we're going to talk about why your data warehouse should be your CDP, or customer data platform. And then Ash is actually going to give a demo, a pre-recorded demo on how MyMuscleChef, a leading consumer brand in Australia, is actually powering their whole marketing stack with the data warehouse. So first off, what's reverse ETL? Reverse ETL is really about the last mile of analytics, so making data actionable. As you can see in a typical modern data stack, you have solutions like Fivetran or even a Snowplow, taking data, putting it into the data warehouse, event data and object data respectively. Inside the data warehouse, you might have solutions like dbt actually transforming that data into best of class models. So you might have dbt making a model in the warehouse for what's a customer, what are they doing in your app, what's their revenue, what's the risk of churning. And then the most typical way to use that data in the data warehouse is actually to just use it to power business intelligence. So you can build reports in tools like Looker or tools like Mode or tools like Tableau to actually show that information to your different business stakeholders around a company, to be able to plot it, draw graphs, build tables, anything like that. And what we're proposing with reverse ETL is actually a new way to surface information from the data warehouse. So instead of just using reports, the idea behind reverse ETL is that you can actually take that data and move it to the systems that business teams are using across your company, whether that's a CRM on the sales side, an ad platform on the marketing side, or even a platform like Marketo or Gainsight. So to zoom out a bit, ETL and ELT basically move data from data sources like Salesforce, Google Ads, Marketo, you name it, into the data warehouse. This is a pretty mature market with players like Fivetran leading the space. And reverse ETL is what we focus on at HighTouch, which is basically a SaaS service to help you move model data, so from your data warehouse back into SaaS tools. And typically here, you're going to be moving model data, so not raw data, but actually data that is a more higher level definition of what a customer is, some key attributes about them, and things like that. And you'll be taking this data and actually just putting it into systems that are already used around the company. So first off, we've covered what reverse ETL is and what it actually means. Now we want to talk about this idea of a CDP, because there's a lot of people talking about using reverse ETL to turn their data warehouse into a CDP. So a CDP is a customer data platform, and it's another buzzword that's taking off, but more so than in the data space, it's more taking off in the marketing space. And basically, all consumer companies are looking for a CDP of some sort. And if you really ask me what a CDP really is, it's basically a database that holds all your customer information, has some sort of point and click UI that allows you to transform it and build it into a model that makes sense for your company, and then has a sort of activation layer to help you move that data to different systems around the company. And a lot of companies have been buying these off-the-shelf CDPs like Segment or mParticle or Action IQ. And really what we're proposing at HighTouch is to use your warehouse as a CDP instead. So we'll dive a bit into why this approach is taking off for reverse ETL and kind of turning your warehouse into a CDP versus off-the-shelf solutions like Segment. For some context and background, I actually used to work at Segment. I was an early engineer there, one of the earliest engineers of the company, and helped them build a number of their products, including their kind of CDP offering for marketers to come in and turn Segment not just into like a bus of data around your company, but also a source of truth for all your customer information and allow you to move it to different places like Facebook ads, Google ads, etc. And that's actually where we got the idea for HighTouch. And there are a couple problems we noticed at Segment that actually made us realize that the data warehouse should be your CDP, not some sort of proprietary off-the-shelf platform. So first, what we realized was that CDPs aren't really the single source of truth. If you adopt a new platform like an off-the-shelf CDP, like a Segment or mParticle, you start to realize quickly that it doesn't have all the data you need. Even if you implement something like Segment's Analytics.js library on your website or the equivalent on your mobile app, or send a few events to it here and there, it doesn't have all the data because the rest of your company and the rest of the ecosystem, when you think about players like Fivetran, Snowplow, etc., are really investing in the CDP as a data warehouse as a source of truth. All these solutions kind of write into the data warehouse, and few of these solutions actually can natively write into a CDP solution. So more and more, we started realizing that at companies above a certain size, the data warehouse was the only place where companies really had all their data, and that CDPs only had a partial view of the world. The next thing that we realized was that CDPs require you to track all your data and events in kind of their own format. And in a large company, like the enterprises we work with, like AutoTrader, for example, this can take months and months to implement just for part of the organization. And as you add more features, it takes more time to implement and implement again. Whereas if you're using your data warehouse as kind of the CDP, or turning your data warehouse into the CDP with a solution like HighTouch, you can actually get going right away. As soon as data is in your warehouse, whether it's from Fivetran, Snowplow, custom ETL pipes you've written in-house, it can immediately be used inside of HighTouch to move it to different systems across ad platforms, marketing platforms, sales platforms, and you don't have to do any extra steps. The next couple points are pretty straightforward. Given that CDPs are proprietary software and not really and kind of try to run the data warehouse of themselves, you can't really use solutions like DBT on top. You can't really orchestrate them with solutions like Airflow. You can't visualize the data inside of them in solutions like Looker. And they're kind of, they don't really mesh with the way data teams operate and kind of the best of breed modern data stack. Our theory at HighTouch is that marketing and data teams should be able to work together. And we think with the right solution on top, the data warehouse can still be a platform where that's possible. The last thing is that CDPs aren't so flexible. You're kind of locked into their own data model. They don't really support you to have your own custom objects that make sense for your company, like a products collection. And they don't really benefit from everything that's happening and all the innovation that's happening in the data ecosystem, like many of the technologies that have been covered today at this conference. So the first thing we provide at HighTouch is really just the ability to use the process of reverse ETL to take any data from the data warehouse, basically write a SQL query and map it to any system. So you can say, I want this data from data warehouse to show up in Salesforce, or I want this data from data warehouse to populate this custom audience in Facebook, or I want this table in the data warehouse to show up as this table inside of NetSuite. But what we've also built at HiTouch and launched recently is this product called Audiences, which basically is under the theory that this capability of reverse ETL should be accessible to more and more people around a company, and particularly marketers. There's a super common workflow we noticed amongst many of our customers, like My Muscle Chef, where marketers were telling data people to change a SQL query and create a new sync in HiTouch. And as a result, we actually built an audience builder that looks very much like the type of audience builder you'd see inside of a product, instead of a CDP product like Segment or mParticle, but it sits directly on top of your data warehouse and can directly query any data there. And you can get started with it if you just have a SQL query or two. So that's enough talking about reverse ETL and kind of CDPs at a high level. What we wanted to cover next is actually inviting Ash from My Muscle Chef, who manages data and analytics there, to talk about how My Muscle Chef is actually using the data warehouse and HiTouch to power their whole marketing stack, where they're running tons of campaigns to hundreds of thousands, if not millions and more of users every single day. Cool. Ash, do you want to run us through a bit of what My Muscle Chef was trying to accomplish when they kind of looked towards the CDP and reverse ETL space, and some of the challenges that you were facing in the organization today?
Yeah, absolutely, and I think you covered a lot of those sort of challenges just now. Things around having all of our data is in BigQuery, which is our analytics warehouse, and so that's kind of where all the raw data goes. That's where we model it for the actually getting the insights and analysis out of there. And in order to connect to other platforms, whether it's Facebook ads, Google ads, or in a CRM or marketing automation platform, it was either manual CSVs, which are not something that anyone really wants to do all of the time, but also otherwise it was creating different APIs, and so again, not super scalable, just takes up a lot of time and is quite sort of rigid in terms of if we need to make changes. And another thing that we kind of found a lot is if there are these sort of intermediary platforms, so from BigQuery into a CRM, and then going from there getting pushed into advertising platforms, it meant that a lot of the time if there was any issues, it was unclear as to what was actually going on. Just different platforms handle and process data differently. So yeah, it was a lot of manual work required to actually get our data into the places that we needed to activate against it. There were inaccuracies, inconsistencies, and so it was a very time-consuming and not a fun sort of process for anything especially from the marketing side. If they needed audience to be updated, obviously CSVs are not the most up-to-date. It's out of date as soon as you've exported it. So we needed something that was going to make sure data freshness was up to the expectations of the marketing team, make sure everything was accurate, and also minimize that sort of manual work that my team had to do.
Yeah, totally makes sense. I think the thing that was most memorable when I first talked to you, Ash, about HiTouch was that you told me you're doing this all manually today. You were taking SQL queries, using a BI tool to export them to a CSV, transform it a bit in Excel, and then move it over to every marketing tool that the marketing team wanted to use, whether it's Facebook ads, Google ads, etc. And as soon as it's exported, it's already out of date. And that's really the kind of thing that we automate at HiTouch. If there's any sort of process around the company where you're taking a CSV and putting it in another system, you can think of HiTouch as a way to just do that at a really high scale. And that's actually the whole idea behind reverse ETL, allowing you to take any sort of SQL queries or data in the warehouse and turn them the source of truth or the database that powers the rest of the systems around your company. Yeah, it would be interesting to hear a bit about the goal of building a customer data platform using, the data warehouse and reverse ETL, but the goal of building a customer data platform at My Muscle Chef.
Yeah, absolutely. And I think you again touched on earlier around CDP is like a really big buzzword in marketing circles at the moment. So there's been a number of times that's been raised and sort of discussed with our team. And for us, you're 100% right in terms of we want to maintain one source of truth, which is BigQuery, but then also be able to activate and utilize it in the same way that a CDP would kind of essentially allow us to. So having a consistent view of the customer based on their transactions, based on their activity on our website or in our app, using like that snowplow behavioral data, and being able to have a consistent view of all of these bits and pieces together that is then able to be accessed and used consistently across across marketing or across like customer support, and to then help with personalization of content, but also for helping our support team more effectively respond to customer queries by having more information about those customers to address them quickly, the accuracy sort of piece, the fewer places we have to actually look for where there's issues. If something doesn't look quite right, if it's not showing up as expected, it's a lot easier when it is all from BigQuery. We know that's correct,
Totally makes sense. So we talked a bit about this earlier, but basically, with CDPs, the issue that companies like My Muscle Chef felt is that it wasn't, they try to do a lot of things, but they don't really focus on the best of breed solution. So with the data warehouse, you basically get more of a composable CDP by being able to take event data, object data that's flowing into the data warehouse via your existing solutions like Snowplow and Fivetran that you may have first implemented for analytics. And then with a tool like HighTouch on top, HighTouch just has to do really one thing, which is helping you sync that data to various different tools rather than doing event collection, transformation like dbt, and syncing all in one platform that lives in a totally isolated world compared to everything you're doing in data and analytics around the data warehouse. It would be great to hear a bit about how you're using HighTouch today at My Muscle Chef, Ash.
Yeah, absolutely. And so as mentioned, BigQuery, literally all of our sort of analysis and modeling, everything kind of goes in there. And then we push using HighTouch. So those from the sort of final tables, push those audiences into Facebook audiences, Google ads. So then we can either, whether it's a re-engagement campaign, whether it's communicating new meals and offers, and actually engage with more personalized advertising and more efficient advertising as well, which is really good, really important for the marketing side of things, and then as well from that lifecycle marketing and comms in terms of being able to target emails, SMSs based on actions they've taken on the website and the app, or whether they've spoken to customer support, showing them relevant offers and products, and so just basically we are able to. We know who these customers are, so we can get them actual relevant and timely communications, which is much less annoying for customers. They respond a lot better to things that are actually kind of relevant and of interest to them.
Yeah, it definitely makes sense. I think another thing that's cool about reverse ETL is, unlike CDPs, which typically are just user data or event data, with reverse ETL you can really take any sort of data from the data warehouse and map it to any sort of other data inside of an answering tool. So I know you all are powering things like audience lists, catalogs, like things like product catalogs inside of solutions like Facebook that can be used for dynamic advertising, conversion events that can be used to actually optimize the ads and analyze how they're performing, all the way down to things like user profiles and inside of your lifecycle and communication tools. So it's kind of insane, but by nature, HighTouch doesn't really have to have a schema, which makes it support a lot more different destinations. We even have customers doing things like powering financial systems like NetSuite off the data warehouse using reverse ETL. Sweet. With that said, let's dive into a demo of what it would actually look like to create these sort of Google Ads and marketing tool syncs directly off the data warehouse using reverse ETL.
So we're in our HighTouch account now. So we've got Google BigQuery configured as our source here, which is our analytics database. Before we started working with HighTouch, we were having to manually set up and manage a bunch of APIs to get the customer data from BigQuery into other platforms like Facebook ads, Google ads, or like email marketing platforms. And so that's kind of time consuming and not the most scalable solution. So HighTouch really enabled us to unlock a lot of the value from our database. By easily updating these audiences, easily creating or changing them, and also making sure that everything is up to date and reliable. Everything's coming from our source of truth, and so we only need to maintain that data quality there, and not have to manage it in multiple different places if there was sort of an intermediary between it. So I'll show you one example of a sync that we've got set up. So this is a model in HighTouch, which is our A and B grade customers. So that's we've got a grading method that is run within BigQuery to grade customers, and so A and B grade are our high value customers, and the at risk piece means that it's been a certain period of time between since their last order. So what we are trying to do with this audience is target those customers with comms on Facebook ads in order to kind of win them back, re-engage them before they officially churn out. So as you can see, we've got this set up. The model set up as a SQL query, which defines the audience, and then it's synced straight through to Facebook ads. The really good thing about the HighTouch piece is they automatically hash the PII for us. So that's one less thing for my team to have to manage in BigQuery, or kind of in terms of getting that data ready. And HighTouch also doesn't store any of that data. So it's just kind of a conduit passing it through from BigQuery into Facebook ads. So from that kind of privacy perspective, it's really simple and kind of good, takes care of a lot of that stuff for us. And here you can sort of see as we're syncing from the model into Facebook audiences, the mapping is super easy just to drop down. So email and then choosing the field that it matches to from the Facebook end. Super easy. And then one of the biggest challenges that we typically face when you're syncing from anywhere into other platforms is data freshness. And so if there's, data isn't up to date, then you can kind of send people the wrong messaging, potentially things that are irrelevant. And that's kind of when ads or comms, whether it's email, SMS, Facebook, that gets a bit annoying. So if it's not relevant to those customers. So here in HighTouch, in the schedule sort of piece, we can set up the schedule for the model in the sync to run manually. So whether that's sort of like on a time schedule, hourly, daily, weekly, but also we use DBT for a lot of our transformation. So being able to connect HighTouch to DBT means that as soon as a job has run in DBT, that then triggers the sync. So as soon as we get that most up-to-date information in BigQuery, that's automatically pushed straight through into Facebook, so, or wherever we're trying to send that to. So, and again, super simple. We just sort of it's a drop down. You choose the relevant job, and then you're all set. Another really useful feature for us is being able to set up Slack alerts. So we've got a dedicated channel for notifications of potential errors. So the Slack integration means that if there's an issue with any of the syncs, we get a notification, so we can then, we're notified in a timely manner, so we're able to address that as soon as possible, instead of assuming everything is just all right, and then finding out at some point that something wasn't working and we've been using incorrect data for a while. So that makes our job a lot easier. We don't have to, feel that sort of stress, that pressure to always be going in and checking things just to make sure that everything is okay. So that's a really big win for us. And I think from here, for my team, we use SQL for everything, BigQuery, DBT. So it's really easy for us to set up these audiences. But for marketing teams who don't use SQL, it's still, there's that kind of disconnect. They need to submit a ticket to us to create or update an audience based on their sort of needs, and then we do that, and then it kind of appears. But a really kind of big piece in terms of enabling marketing teams to be able to use data more effectively is giving them more sort of control and access to it. So there's a new feature in High Touch, which we're in the process of setting up, called Audiences, which is essentially like a visual editor for building these models. So instead of having to create a query using SQL, marketing gets to use an interface that they're like familiar with from other like email marketing platforms or audience creation platforms, where it's drop downs, conditions to include or exclude people into their audience, and so it gives them more ability, more control, like autonomy over how they can access and utilize that data without having to always use us as that intermediary between it. And that seems really simple, but the value is actually really massive, because my team only needs to manage our one source of truth, which is BigQuery, and then we know that if there are any issues, we can go in and troubleshoot, because we know that if any sort of problems are going to be either in BigQuery, or it'll be a simple kind of like setup that like configuration error. So we're able to then easily troubleshoot a lot of that sort of any kind of issues that arise, and we don't have to worry about inconsistencies that occur from sending data via multiple platforms in order to get to the final state. So if we were to send all of our data from BigQuery into a CDP or a CRM, and then from there you set conditions which then go into advertising platforms or email marketing platforms, there's quite often we've found that there are inconsistencies just based on the way that different platforms hold or handle data. So the potential points where there are issues, it just kind of, they just all add up. So it means troubleshooting or QAing things is quite a time-consuming process. So with this, it means that there's only either the data's wrong in BigQuery, or there's a configuration error within the audience in High Touch. So there's only two places, and so it's super easy for our team to be able to manage and maintain data accuracy and freshness, really, in wherever we sort of need to use it.
Wow, thank you so much, guys, Tejas and Ashley. First of all, welcome, and thank you for that insightful talk. I think you touched upon two key points for any customer data platform, which is the single source of truth and how exactly you can take the value out of it in a quick way. Once again, I would like to remind the chat to ask any questions if they have. One question from my side: how fast can you do reverse ETL? Is it more like a batch or a streaming thing?
Yeah, it's a great question. So with regards to speed of reverse ETL, it's somewhere in between. So actually, we have customers doing things as low as basically every minute through reverse ETL. Some of the data warehouses like BigQuery can be written into in a streaming way, which is super powerful. And they even have like a streaming API for this in Google BigQuery. And then on High Touch side, if we're syncing, let's say, event data out to a system like Facebook, or any sort of like timestamp sortable data, we can actually use like timestamp partition tables or sort keys in Redshift or the equivalent in Snowflake to pull only the latest data without even scanning all the old data inside of the data warehouse, which makes it possible to do actually streaming operations off the data warehouse in High Touch. Another interesting thing is like whenever we sync to any destination, even if it's like, updatable data, like all your users, High Touch only sends the changes. Like we have this change data capture process that we run before syncing anything to Facebook ads, Google Ads, NetSuite, Salesforce, whatever destination it is. So we're only going to sync the changes, so it can be run at pretty fast schedules for that reason.
Great, great. Thanks for the clarification. We have a question from the audience. Anan Khan is asking, can I set up my own destinations in HighTouch? For example, if I want to send data from my warehouse to in-house custom tools.
Yeah, that's actually a great question. So for like most SaaS products, especially if it's a sales or marketing tool or an ad platform, at HighTouch, we've decided that a big part of the value we provide is to build destinations for our customers. So we have like 70 plus destinations, and probably will have over 100 in near time. That said, we've realized that we can't build destinations for everything. Sometimes people have in-house tools. Some of our largest customers, like retail customers, for example, have like in-house CRMs and products like that. I believe Nando's Chicken in the UK has in-house CRM, for example. And for these sort of customers, like they can actually build their own destinations on the HighTouch platform. We have like a framework called Custom Destinations. You can see it in our docs online, and it allows you to build your own destination in HighTouch. Even the UI of it that gets shown to like analysts using the HighTouch platform, so that anyone can do self-service reverse ETL to even an in-house tool, just like they could do to Salesforce.
Yeah, that makes sense. And a question from my side, Tejas, how do you manage security? I know that you actually talk about that there is no retention in HighTouch, but how do you manage the security of the data for your clients?
Yeah, it's a great question. So one thing that we have at HighTouch is called we call it the hybrid architecture. The idea there is that while we operate as a SaaS service, that makes it really easy. By operating as a SaaS service, we make it really easy for customers to use the product. They can just like sign in, connect the warehouse, connect the system like Salesforce, and start moving data right away. They don't have to run any code on their end or anything like that. But we have this thing called a hybrid architecture, which means that the customer can provide their own like Amazon S3 bucket, which we store everything we need, like the state of the application in there, instead of in our own end. So HighTouch doesn't even to power like our UIs, like the live debugger you get, where you can inspect the rows going through HighTouch and any errors or API calls or whatever is being done under the hood. Even for those features, we don't even store information on our database about your data. We just store it in that S3 bucket or Google Cloud bucket or Azure bucket, and just store kind of pointers to where to look in those systems like S3 and Google Cloud storage on our end. So we're not storing the actual data, just storing like file names and stuff like that, so that we can still provide like a really good SaaS type user experience without actually storing data on our end. And that's how financial tech companies that you can see on our website, like Blend or Plaid or Betterment, actually use our products, and same with healthcare companies.
Oh, good point. Okay, great use cases. Yeah, thank you very much.
Awesome. Thank you for having us.
Thank you, Ashley. It was great meeting you.
Thanks so much, guys.
Okay. We're going to quickly go into a lunch break now.
Yeah, I think that we had a great morning session today, Aditya. Thank you for having me this morning and sharing with me this space for our great audience. I think that we had a great afternoon lineup today.
Yep. So we're gonna have a lunch break till 1:10, and then our afternoon lineup. We're gonna have some great talks as well. At 1:10 p.m., we have Pip Sidaway, who's gonna talk about their journey to the cloud using Snowflake and DBT. At 1:40 p.m., we have Jack Dillon, who's gonna talk about situational intelligence with analytics in motion. 2:10 p.m., Elizabeth Antoine is coming to talk about the Albedo decision tree, when to use what in the Azure data estate. And we have at 2:40 p.m. Rohit Srivastav, who's going to talk about scaling proximity targeting via Delta Lakehouse based data platform ecosystem. Some more interesting talks coming your way, guys.
Exciting. So we are going to close the day 3 with a great session. So we will see you all this afternoon.
Yep. See you.
Thank you.
Good afternoon and welcome back to DataEng Conference. I hope you've had a wonderful conference so far. This is our last afternoon of talks, and we've got some fascinating talks coming up. But first, I'd like to thank our hosts for this morning, Tiru and Aditya. Thank you for all your time. I found the data quality talk from Simon O'Toole around astronomical data was out of this world. So yeah, really good one and highly recommended if you're just flipping through some of these to revisit that one. I found that quite enjoyable. So my name is Noel Hansons. I'm the acting Director of Cloud Enablement and Data Engineering at Lifeblood. A fun fact of mine is that my dream is to cycle across Europe with my family from north to south. And hopefully one day I'll be famous for that because I'm not famous for anything else right now. This afternoon we have a number of fascinating talks. First up will be Pip Sidaway and Juliana Zhu speaking around Snowflake and DBT, our journey to the cloud. Coming up after that will be Jag Dillon speaking about situational intelligence with analytics in motion. After that, Elizabeth Antoine, Andrei Zykov, and Elena Santorini speaking about Albero, decision tree, when to use what, the full Azure data estate. And then Rohit Srivastava and Bikash Singh speaking about scaling proximity targeting via Delta Lakehouse-based data platform ecosystems. So a thank you again to our sponsors for their support. So Snowflake, Fivetran, Databricks, Microsoft Azure, AWS, Imply, Versor, DBT, ThoughtWorks, HighTouch, Microsoft Reactor, Yao, and Cloud Shuttle. And also a thank you to all of our organisers and committee speakers and panel hosts so far. Naturally, if you've got any questions to ask, please ask them on YouTube and continue with our conversations on Slack. And naturally, we have a code of conduct to create a safe space for us to have our discussion of ideas and our contest of ideas and our sharing of ideas. So that's really exciting. All right, so we'll now move on to our first talk for this afternoon, which is Pip and Juliana speaking about their Snowflake and DBT, their journey to the cloud. So Pip is the Senior Analytics Engineer at the NIB Group, and Juliana is a data engineer at NIB Group. And Juliana tells me that she's famous for her rendition of Lose Yourself by Eminem at karaoke, which is awesome. And Pip has a fun fact of installing a new car stereo in her car over the long weekend, which is cool. I've done that myself and I know how much fun it can be. And also having a wide range of hobbies everywhere from cake decorating, nanocrafts, crocheting, laser cutting, gardening, basically anything she'll give a go to. So without any delay, we'll introduce Pip and Juliana and listen to their talk.
Hi, welcome to our presentation. So we're going to talk about NIB's journey to the cloud, so using Snowflake and DBT. So NIB's been around since 1952. It's a trusted international health partner. So we're about empowering our members to make better decisions and improve health outcomes through greater accessibility to affordable health services and information. And so we sell travel insurance, medical insurance, and health insurance, and we're a global company. So my name is Pip. I'm an analytics engineer in our emerging technology and data platforms team. So today I'm going to be talking about a bit about DBT, some testing and linting.
And hi, I'm Jules. I'm a data engineer here at NIB, and I'll be talking about our overall data vision and how we're using Snowflake and also pipelines for CI/CD. So our overall vision is that we want to move away from using data as a service and to work with data as a product, which means that we want to work with and own data in a distributed way and enable self-service for every data user in the company. So that means that we have a pretty huge set of challenges. It means that we need our data to be high quality and highly available and discoverable, whilst also making sure that we're securing sensitive data, including private health data and also our financial data. So how do Snowflake and dbt fit into this? Let's have a look. This is our tech stack, and like most organizations, we have an ever-evolving constellation of data solutions with a mix of legacy systems as well as applications and serverless microservices. We land all of this data in S3, which is our data lake, and Snowflake is the environment in which we host our data mesh architecture. In the data processing and analytics side, we use dbt as our transformation tool, and on top of that, we use different tools for analytics and reporting depending on the use case. Underlying all of this, we use GitHub and BuildKite for our version control and CI/CD, which helps us to bring software engineering and DevOps best practices into the data space. So, Snowflake. Snowflake, if you haven't heard of it yet, is a cloud-based data warehouse. For us, it's the meeting ground between our data producers and our data consumers, hence the data mesh architecture. So what we like about it is that it's built on familiar conventions, it's got a simple UI, and it scales well and lets us iterate quickly without worrying about things like concurrent use or sizing. And from a data engineering perspective, it's really easy to land data and also create patterns. So we are finding it pretty easy in terms of also managing permissions and features that it offers in privacy access control. So how do we get data into Snowflake to begin with? So we have two main ways of getting data into Snowflake, essentially Snowpipe or Fivetran. With Snowpipe, we have all our operational systems which use Snowpipe dump the files into S3 as landing zone, and then we have a Kinesis firehose set up so that if the S3 bucket finds a file using the S3 event notification on a given bucket prefix, then it will notify the Snowpipe service, and Snowpipe will land data into Snowflake in a given landing table. We have a really nice setup for this, where we have a Dockerized application which will set up the firehose event notification and Snowpipe for you if you set up a YAML configuration for it. And the great thing about that is that you get it in a really nice and consistent format, turns up within minutes, and there's some built-in deduplication based on file names. So one downside that we have experienced so far with this is that it can be a little bit tricky with S3 bucket notifications because sometimes they can clash and override. So eventually we're going to try and move towards using event bridge notifications, but we're still thinking about that because that can introduce some latency. The other way that we have getting data into Snowflake is Fivetran. So Fivetran is really nice. It has some built-in integrations for a large number of data sources already, including Snowflake, including Salesforce and DynamoDB. And this is particularly good for getting data from one of its supported sources, particularly if you want to iterate really quickly, because it's really easy to set up a connector and make sure that everything's coming through. So that's how we get data into Snowflake. Let's have a look at how we're securing the data once it gets there. So with Snowflake security, we want to work together with a large number of users across a number of different disciplines. So we need to make sure we're managing access and ensuring we're following the least privilege principle. So we manage Snowflake permissions using Okta and Snowflake roles. Okta is our identity and access management service. We also, on top of Okta, have an external authorization process for new users to let them access Okta in order to access Snowflake. Once they're in Snowflake, we have a number of different Snowflake roles set up, which we assign to different users depending on the tasks that they need to undertake. So we have a general deploy role, which has basically all the permissions, but we barely give access to anybody for that role, unless they need to make a deployment. Other roles that we have include sysadmins, data engineering, data warehousing, and also business users, each role having a smaller subset of permissions based on the tasks that they need to undertake. All of this we manage using a central repository where changes to role permissions need to go through a approval process, which is nice and transparent. So some of the issues that we've experienced with this are that permissions groups sometimes grow so big that they kind of defeat the purpose, or you have sometimes the other problem where you have so many small roles that they require switching in between them when you're in Snowflake. But generally, we found that Snowflake makes it easy to manage permissions. In terms of privacy, Snowflake also offers encryption of data at rest, as well as things like masking policies. We're still working through the broader issues of how we want to achieve end-to-end encryption and also anonymize data for data analytics. But overall, Snowflake is really handy in that it offers a number of access control, encryption, and other tools that support our overall data security picture. So, Pip will talk about DBT and how we use it for transformations.
Awesome, thanks, Jules. So DBT, so it's short for Data Build Tool. It's a command line tool using SQL code. So it's produced by DBT Labs, formerly known as Fishtown Analytics. So as an analytics engineer, this is a key part of my toolkit. So if this was presented in real life, I'd sort of ask how many people have heard of it. I mean, maybe a bit easier question is how many people haven't heard of it. So there's a lot of articles and things going on around it at the moment. So there's two different formats with DBT. So we've got DBT Core, which is an open source command tool, and DBT Cloud. So we use DBT Core, which we load up in VS Code and with the Snowflake warehouse in the back end. It's pretty awesome. So we were traditionally a ETL shop, so extract, transform, then load to our data mart. However, that would potentially, just to get yesterday's data, would take almost all day just to finish. So in the new world, the cloud world, storage is cheap. So the norm is now to extract, load, and then transform the data so we can just store it there. So DBT looks after that T in ELT, the transform process. So it doesn't extract or load the data, but it's really good at transforming it. So things that are already loaded into Snowflake. So now it's just up to Jules to worry about getting that data into Snowflake for me. So the process when we land everything in Snowflake using DBT, it's just been awesome. So while we don't have all of our legacy stuff there yet, we've seen some massive gains. So one example, a monthly process, it used to take about 8 hours to run, had millions of lines of data. It was reduced to about 30 minutes using Snowflake and DBT. So that makes it a lot more rerunnable if there's a problem. You don't have to say, oh, sorry, we've got to wait till tomorrow. So DBT is growing organically at NIB. So we're always having new people contacting our team wanting to jump on board. We've set up some DBT mentors to help with this, and we have a Slack channel as well. So it's like DBT Guild where people can ask questions, help each other, share interesting new features. They have great articles around the place. DBT also have their own Slack domain that has an amazing community. So everybody's really helpful to help with questions in there if you get really stuck. So DBT uses SQL coding and Ginger, which is a templating language. So SQL seems to be becoming sort of the code of choice again for data warehousing. So there's this movement back towards code-based tools rather than the GUI-based systems. So this potentially allows easy switching between tools as business needs change. DBT Labs' premise behind DBT is about having reusable code. So they use the thing that's called the DAG. It's kind of like the diagram lineage tool and a way to review this to make sure that you're not repeating things from your source. So setting up projects where you just pull out the data from the table once and then everyone can use that same table for their requirements. So software engineering and DevOps best practice. So things like having standards, so code structures, style guide, there's documentation. So DBT has built-in DBT docs, which Jules will cover a bit later. So we're currently in the process of debating our standards. It's a work in progress, but I do love a good set of rules, so I'm pretty motivated to get that sorted. Another thing that's been good, instead of having things that I'm sure you've all had, like the final version instead of just the final version, having the version control and easy to find that revision history using Git. The CI/CD, never knew what this was, but now definitely do. Continuous integration, continuous development. So again, we're using Git branches to be able to do that so that we can all have our own separate areas to work on. And part of our process, we enforce a peer review before going to production so that it makes sure that things are not sneaking through, that people are definitely got another set of eyes over that. So I'll hand over to Jules now. She's going to talk some more about our pipelines.
Thanks, Pip. So we use fairly standard continuous integration pipelines and environments. We have the dev, test, and prod environments. And in Snowflake, these are basically just different databases. In dbt, we have different targets that we point to for dev, test, and prod, and also different roles that we use to access each of these different databases. So this is really powerful because this means that we have a standard template pipeline and also standard sort of utilities and stages which we go through in each of our pipeline steps. And individual dbt projects which we have can customize these steps depending on their needs. So this allows different teams to work across different projects with a common framework. It means you can hop between different repositories and have a basic idea of what's going on. And it's great because just having the same general process is really handy. So our pipeline tool that we use is BuildKite, which I personally love. It means that you can hook up to automatically build any dbt projects that you have on a push to GitHub, and it has the standard steps for each of these builds, including obviously building the project, linting, and then usually we have a step where you can view the result in the Snowflake test database before you promote to prod and generate any documentation. So the great way in which this lets us work together simultaneously is that we can all work on our individual branches, which ensures the integrity of the main branch. And a pattern that we found useful for this is that we append the branch name to the schema or the model in dbt, and then you can do that by overriding the default dbt name macros. And then when we push, the branch is automatically built by BuildKite in the test environment. And because the branch name is across everything, it allows us to identify which objects belong to which particular ticket. We also have some automated cleanup scripts, which are pretty handy, which destroy any non-main branches based on the name after a certain amount of time has gone by. We also find that Snowflake zero copy cloning is pretty handy. Zero copy cloning, if you haven't heard of it before, is when you make a reference to an original object, such as a table or a schema, rather than making an actual copy. So in Snowflake, this only contributes to data storage costs if you modify that object afterwards. And dbt projects which rely on larger tables or views or have a fixed set of sources, we tend to make a zero copy clone of the main production table in dev and test. And this is great because it's efficient, it's cheap, and it lets us work with an up-to-date representative data set, which actually matches production. So Pip will talk a bit now about how dbt and Snowflake support data quality through linting and testing.
Great, thanks, Jules. So testing. So dbt comes with some built-in testing, as well as they have some great documentation on how to build your own custom tests. So while we have done data testing in the past, it's usually after everything's loaded. So any issues that pop up means perhaps a lot of time to rerun things. So even simple testing, like testing that the unique key is unique. Yes, I'm sure we've all been there where they're not unique. And freshness tests as well to check that your data is coming through. The monthly process that I mentioned a bit earlier is an improvement we've made, has also been incorporating the tests into dbt. So comparing like the final data set sums against the original source and against some comparison data sets. So our data analysts have estimated that's probably about 2 days worth of work of trying to get the manual validations. Excuse me. So the pipeline will fail if the tests fail. So it will warn us if something has gone wrong, just in terms of if it's outside of the thresholds that we've set for it. So linting, another favorite of mine. So part of SQL becoming more common and with the DevOps standards, there's a tool that can help called SQL Fluff. So SQL linter basically tidies up your code based on some standards. So I've just provided a small example there, over exaggerated, of course. I would hope nobody would write code like this, but hey, you never know. We've implemented this linting process in our pipeline. So at this stage, it's a warning rather than a failure, but it will be, as we get our standards sorted, it will be something that we'll probably enforce more strongly in the future. So now I'm going to hand over to Jules again. So she's going to chat to us about documentation.
So, docs. Well, DBT projects come with built-in docs, and as you can see on the screen, it's basically a pretty good format. You can generally see a lineage graph and also some details about each of the tables and views and what it contains and that sort of thing. And one of the great things is that it's all in one place. But if you have a large number of different DBT projects, this can be scattered around. Something that we found useful is, because we work across a number of DBT projects in a pretty decentralized manner, we have set up a central repository for docs, which we call DBT Megadocs. It's basically just one DBT project that aggregates all the docs for all of the DBT projects, which we find overall a pretty valuable tool because it helps us track down different data sources and who's using it, and also where different data sources have come from. So that's pretty much it. We'll have a talk about future challenges. So future challenges, obviously, I think every organization has a large number of challenges at all times. For us, the things that we want to do are to keep building on what Snowflake and DBT provide us in terms of tools, because they are helping us make our data more accessible, and they act as this platform and this common language bridge between all of these different teams. But they also come with a number of different challenges, which we have yet to figure out how we're going to work them in to solve. So some of them are improving our data lineage and discoverability, making sure that our docs are also consistent and complete is one part of that. We also want to make sure that we're thinking about privacy and anonymization sort of end to end, and we need to think about whether or not we encrypt data, before it reaches Snowflake, and how we do analysis on it afterwards. If everything's encrypted, whether or not we unencrypt, that sort of thing. One other thing that we want to do is we want to take this cultural shift of distributing data ownership more and more, and getting everybody comfortable with the idea of self-service by making Snowflake the go-to place, and DBT really well understood across the organization, and also doing things like fixing permission creep and balancing our privileges with security, and also just establishing more conventions and consistency across both of those tools.
So our key learnings through onboarding with these tools. So Snowflake enables standardized data pipelines. Snowflake also is really good at balancing permission scope and the security requirements. Using DBT with automated pipelines, so we're using with build, kite, and git, so using the CI/CD best practice. Using linters and DBT docs just to keep things nice and organized and tidy, and the integrated testing has been great for us. So we're keen to hear any questions that you've got. So fire away.
Hi Pip, hi Juliana. Thank you for your presentation. That was fantastic, and I really love these presentations where it gives it's an accurate look inside a real use case from the people that are using this day to day. It's unvarnished, and it's really what you're experiencing, which I quite enjoy. So a couple of questions to begin with. The first question that I've got is around how big the size of your team is and how long you've been on this journey for.
Yeah, so we've got sort of smaller teams. So like I'm on the analytics engineering and data warehousing side. So I think our team's about 6 people. I think Jules, your team's similar size.
Yeah, we're I think at 5 people at the moment, but we're both sort of part of a larger engineering technology platforms team, which I'm actually not sure how many people.
Yeah, it's about, I think we looked at the other day, it's about 29 people in our wider team as well. Yeah. And the second part was how long have we been doing this? So we started with a pilot in DBT the end of last year, so maybe around October, November, about then. So it's relatively new, but we're making huge changes and everyone's just jumping in and having a go.
Yeah, fantastic. So that's not particularly long to be on a journey such as this, but it's amazing to see how much you've really built out in terms of the components that you use in the complexities, some of the workflows and automations and so forth. So to me, that sort of really emphasizes how quickly you can stand these things up and make quite a lot of progress along that path. We've had a question from the floor around how does DBT performance with any data volume testing? I'm assuming that means how does DBT manage performance with any data volume testing?
So like in terms of how much is coming through. So we're like the one that I was talking about in the presentation, we've got like millions, like I think it's up to 90 million rows of data. And so we perform a bunch of tests on that and it's surprisingly quick. So it's like doing sums and grouping and lots of things like that, comparing values. And it's it's super fast. And I think that's a lot to do with Snowflake more than anything. So Snowflake being in the back end, it's using that compute. So I guess DBT is just kind of writing the scripts for that.
Yeah, wonderful. A question I noticed that you had you discussed on your final slide around wanting to work on data discovery and data lineage. You had Edmondson on your sort of application components map. Is that what you're using Edmondson for, and how far along that journey are you?
So we actually are still sort of in the pilot phase. We're just getting together proof of concept and still exploring that, but hopefully we're going to be using that and getting that on board in the near future.
Yep, great. So Paul has asked, are you using DBT Enterprise? And I think you said you're using the DBT Core from memory.
Yeah, so it's like the local tool. So there's the cloud version versus the sort of on-prem one. So we're just using the free open source one at the moment. We haven't gone into the cloud, but it's definitely one of the things we're looking at as we roll out further to the organization. And you have the less technical sort of people who just want stuff to run and just work. So it's definitely something we're going to look at soon.
I'm interested in digging a little bit deeper into that, Pip, around the less technical people. Do you see them as being your pretty traditional sort of GUI report developers, maybe your Power BI developers, or are you seeing reaching even deeper into the organization and putting tools like DBT into their hands?
Yeah, great question. So definitely old GUI based. So we're a lot of us doing SAS, a lot of things on there, which is your point and click and join things together. So we're now seeing again a movement in the data analytics space into SQL as well. So getting into that coding. We've got like frontline sort of operational reporting teams that are also interested in getting into that space. But those are the areas that we'd probably start to push towards the cloud version, just because it's less overhead and that sort of thing in terms of looking after just some of that stuff that you have with the open source tool.
Yep. Yeah, wonderful. Thank you. And Josh has asked a great question. Why was the decision for BuildKite made over DBT Cloud or Airflow for orchestration?
Do you want me to take this, Jules?
I'm actually not sure. Yeah, I think the decision was made before I started, actually.
Yeah, so again, I think this is just part of our journey. So it's very topical. I've been talking to Josh this morning. So as part of like the proof of concept, we were using BuildKite, and as we're building out more models, we're now starting to get orchestration challenges. So we're trying to push these things into the bash script using the pipeline. And so we're trying to now move into the next phase of, okay, maybe we need a bit of an orchestration tool that's not built quite so it works just for running things that are able to go. But when you start to get dependencies like your on-premise data sets that we're pulling into Snowflake and just waiting for them to be available and they're not part of your DBT project. So currently orchestration is definitely one of our challenges we're working on. So yeah, very, very topical.
And do you have a I'm not sure whether I saw a data lake as part of your architecture there.
Yeah, so basically S3, we put all our data there and we kind of use that as a data lake.
Yeah. Okay. Great. I must have missed that on the components part. Wonderful. Well, thank you both for coming today and speaking. That was a fascinating talk and great to hear about your journey along the ways. And wish you all the best in future.
Great. Thank you very much.
Thank you so much.
Thanks, Juliana. All right. Now, shifting on to our next speaker, Jag Dillon, who is a business analyst from Queensland Energy. And so Jag will be talking today around situational intelligence with analytics in motion. And he speaks here about the growth of streaming data is a massive industry trend in enterprise tech. The movement towards streaming data provides organizations with new intelligence. Connecting applications and streaming data can unlock all these insights about what's happening in real time. In this talk, we will share how this new data architecture can help organizations unlock the potential of data by enabling them to have rapid interactive conversations and the ability to process massive data in real time across all their data. So we'll hear from Jag now and come back for Q&A at the end of this video. Thank you.
Hi, my name is Jag, and the next half an hour, I will explain to you about analytics in motion. The topic of discussion over here is situational intelligence with analytics in motion. Now, let's start with time. Everyone knows time is money, but what about real time? Real time is where you can make a decision faster or make a better quality of service to your customer, whether it's internal or external. And that's what we mean here by real time is money. Now, streaming data gets you halfway. Analytics takes you all the way. If you look at in terms of value from a real-time operations point of view, what is happening right now, you can see you have visibility in the moment. But when you go to the next level, we should talk about context-aware decisions where you can have real-time and historical events. What's happening today compared to what happened a week ago? That gives you intelligence. Then when you start having interactive conversations where you can allow your users, whether they're internal or external, to rapidly explore all your data. Why is it happening? That's where you get the bulk of the value, right? So that's what we mean by analytics that gives you all the way. Now, what if you could take advantage of every second? You could maximize customer sales and revenue. You could understand the real-time customer behavior to optimize your targeting and promotions, right? Imagine any digital apps that you might have or digital business that you're running. You want to ensure your customers get the best return on service or revenue. You want to have that visibility in real time. That's what I mean by having advantage of every second. You want to ensure operations never go down so that your systems are running and is giving you real-time observability to eliminate downtime or security threats, which is also growing as we speak. You want to build a better user experience where you have real-time application, cloud, and service monitoring and diagnostics. And then last but not least, you want to deliver insights as a service, where real-time analytics is monetized and delivered to customers as an extra value to you and the customer. Therefore, you're actually getting revenue out of getting real-time analytics to your customers. So that's what we mean by taking advantage of every second. Real-time is money. Now, harnessing this potential requires a new approach to analytics. From the left, you have streaming analytics, which is designed to process event streams via predefined queries in real time. Then, in the center, you have batch analytics, which is designed for reporting on historical aggregations. Analytics in motion is a combination of real-time and historical. So it's a combination of both streaming analytics and batch analytics. It's designed for real-time interactive insights on all of your data. That's what we mean by a new approach to analytics. Analytics in motion can be built with sub-second query response at virtually limitless scale. How can you analyze millions of real-time events every second? How can you support slicing and dicing for thousands of concurrent users? On the left-hand side is an example of how users are currently using analytics in motion and how they want to view information today compared to 7 days ago. That gives you a quick insight of what we're talking about here. Now, let's talk about the existing solutions out there. You got cloud data warehouses, which are designed for traditional reporting and dashboards of historical data. And data warehouses as a service, which is organized by the cloud companies like Amazon, AWS, Google, BigQuery, they are a service which simplifies management and scaling complexity of legacy enterprise data warehouses. So all you've done is just taken your data warehouse from your on-prem to the cloud, but the problem has not gone away. You just reduce your overheads. The architecture is only suitable for low query volumes and traditional batch analytics, right? In this new world, we need end users to explore real-time data and rapidly process interactive queries. Meeting the scale and concurrency requirements drives very high expenses. Think about it this way. The cloud data warehouses tend to separate compute from storage. The more users that are going to run queries, the higher your cost goes up. Therefore, they're not designed for that analytics in motion use cases. Event streams, the Kafkas, the Kinesis, these generate, these event streams processes events immediately as the data arrives. The architecture is predefined queries to calculate results for real-time alerts. Great, but these engines aren't capable of true analysis and exploration of high-dimensional, complex data at scale, or even correlate and aggregate across real-time and historical data. That's a challenge there, which takes us to search platforms, the Splunks, the Elastics, which are great for terabytes of scale built for a couple of users, whether they're security guys or IT guys. It's amazing. However, these platforms aren't able to meet the scale or high dimensionality or concurrency and flexibility required for ad hoc analysis of real-time and historical data, i.e. the moment you want to expose it to more users. That's where these search systems are not designed for those sort of use cases. So these are the requirements for analytics in motion. You need to have interactive queries where you need to have sub-second OLAP responses. You need to have self-service data analytics, and you need to have a point and explore integrated user interface. It also has to have unlimited scale. It can handle high query concurrency, petabytes of data or volumes, high ingestion throughput, right? It has to be able to handle real-time and historical data, the Kafka and Kinesis integrations, the data lake integrations, and flexible and adaptive schemas. But it also needs to be the best price performance, right? That's important. You need to be configurable price performance, predictable performance and cost, and fine-tuned based on usage. So these are the 4 requirements for analytics in motion. And imply is the answer. It's built from the proven Apache Druid to power real-time analytics and data application. It's built to never fly blind again, with access to data the moment it's created. It's built to have live conversations with data at any scale or any number of users. And it's built to not break the bank with a hyper-efficient data architecture. Now, from a top level, this is the Imply Analytics platform. It pretty much combines of Imply Druid, which is the engine, which is the workhorse, and it can run on either AWS or Google Cloud or Azure or even on-prem. It can handle both streaming and batch ingest, and it's the fastest query engine out there. You need Imply Manager, which comes part of the solution, which helps you do simple cluster management. It handles instant deployment and scalability. And then you need to tune as your data goes. Imply Clarity, which helps you improve your performance as the system is used over the time, performance monitoring and resource optimization. And of course, you need to have a user interface, which is Imply Pivot, right? Or you can integrate it with your custom user interface, or you might be using a Tableau where you want to have real-time information being integrated via the JDBC. So that's the Imply Analytics platform from a high level. And Imply Pivot is what our user interface that is specifically designed to run on top of Druid. It allows you to have audited and controlled personalized experiences. It allows you to have a complete picture of streaming and historical events. It's got intuitive visuals with drag and drop, slice and dice. It's got real-time dashboards to inform you and inspire curiosity. And most importantly, it's got built-in security for user management and alerting. So therefore, you can answer complex questions at scale instantly. Here's a high-level data architecture flow of Imply. You'll have your data sources coming in from the left, your data delivery mechanism like Kafka or Kinesis, sending the data into Imply for ingestion. Or you might be sending your data sources into a data processing system, an ETL platform or machine learning platform, which can then be stored in your data lake or Hadoop storage, which will be then ingested into Imply's batch and compared with the real-time data that is arriving via your Kafka Kinesis, and Imply feeds it to your application. But this is a high-level architecture flow of Imply. Now, our customers themselves who have tested it and deployed it have told us that the results are much faster. The queries run 3 to 5 times faster. The cost is less than 50% of what the TCO of other analytical databases that they have invested in, and it supports more users for the same hardware. So that's the power that the customers have told us. Now, let's talk about some of the examples of our customers in action. Twitter. Now, Twitter owns a company called Mopub, right? Mopub is basically a revenue generating platform that runs on top of Twitter's platform, right? And as you can imagine, it's a large part of the revenue. Mopub is programmatically connecting advertisers with publishers, right? And the stakeholders need to understand how the ad platform performance is. And the external stakeholders also need to understand the detailed ad campaign performance. Who are the people who are clicking on your ads? Where are they located? How is your new campaign working? And that will give you answers faster. They had existing tools which were costly and inefficient. So therefore, they had tried with every single cloud provider out there. They couldn't get what they were after. In the end, they came with Imply, and they wanted a system that would handle 100 billion events per day, which could run up to high costs on other cloud company providers. But they also had data governance and compliance risk issues like GDPR out of the European Union. Imply was deployed, it's self-hosted and white labeled, right? So they have got both thousands of internal and external users running queries in real time, right? And the users are getting more information and they're growing, right? The external advertising product generates real revenue for the company. And they are using Imply as part of the service to their customers, right? It's reduced their TCO by 10 times and it's fully GDPR compliant. Therefore, the data that happens in Europe stays in Europe. Data happens in Australia will stay in Australia, and similarly to other geographies out there. It's self-hosted with predictable and controllable costs. So you have both internal and external users using Imply in Twitter for ad auction data. External users are the publishers, are the advertisers. How successful is my digital advertising campaign? Internal users are the engineering team. How is version A compared to version B of the Twitter platform? How is version B compared to version C of the Twitter platform? The marketing team, how are the number of users coming in? How are the uptake of Twitter feeds when the US election is on or when COVID is hitting New South Wales? And you have analysts who would like to get details, all from the same data, right? And this is where the power of Imply having analytics in motion comes in. Let's take a look at it from another example. A bank, DBS Bank is the largest bank in Singapore. They are using us from an anti-money laundering use case. And you can imagine they've got all sort of solutions out there in the bank, right? You have banking transactions that are taking place. and the banking transactions are coming in, being ingested, and they're comparing it to their machine learning models. However, you still need human interaction to ensure those machine learning models are correct. And when you have lots of data coming in real time, I mean, everyone is transferring money as we speak. So you can just imagine, right, the millions of events that are happening in real time and millions of events, billions of events from historical. You want to compare that. Imply is being used by the banking analysts. They don't have to be technical users. They're banking analysts. They understand the business. They understand fraud. They understand anti-money laundering. They are using Imply to do their own self-service analytics. They're using Imply Pivot to slice and dice to get in answers. A banking analyst in Singapore and a banking analyst in Hong Kong and a banking analyst in New York are all looking at it differently. And that's what Imply provides them to power their customers, whether they're internal or external. Now, this has helped them to be more proactive, right? Because they can check for real-time data visibility, so they can provide detection and alert faster, so that they don't get fined by their respective countries. It can scale into millions of events per day with 500 milliseconds end-to-end latency. And it works with your machine learning enablement. So therefore, you can see as your machine learning algorithms are running and the results that are coming out, you can modify or you can reject the machine learning algorithms based on the business information that you have. Let's look at it from a manufacturing point of view. Here's a supply chain analytics company. It's a large electronic consumer provider, and they were using Oracle as their their system in all of their manufacturing plants. In particular, it was more the large plants. There was no single consolidated view of manufacturing supply chain, right? So all the reports were being generated after a shift had completed, and these shifts are running 24/7. So they'll have multiple shifts per day per plant, and they had to have someone consolidate all of this data together so that the users can have a consistent view rather than have a fractured view, and they were spending a lot of time on reconciliation. Today, they're using Imply. So they have a consolidated view of monitoring, reporting, and analytics across all the plants, whether how big or how small. They have immediate explanation of anomalies during a shift, not after a shift. And they don't have to spend time for reconciliation because they're getting all the data into Imply that they can compare what's happening in real time and what's happening to historical. And these workflows have led to expanded use. So now they've got 10,000 global users issuing over 1,000 queries per second, and they can get immediate explanation of anomalies during a shift. So immediately they can tell if a manufacturing plant is having problems. Immediately they can tell if there's some defects happening in one plant, because all these plants are interconnected in terms of the supply chain, right? And most importantly, they can also help them reduce fraud, when previously they used to have a lot of black markets where they were selling malfunction devices, devices that were deployed from any of their factories that were being sold in the black market, and those people who were buying it from the black market or walking into these customers' retail stores, they were able to pinpoint immediately that if that item is part of the malfunction device, it's not covered by warranty. That has saved them $1 billion a year, right? So that's an example of how Imply is using many use cases, right? Not just fraud, but also for fast root cause analysis to understand product defects found in return goods, right? Or faster detection of faulty components or software tests and process in a certain manufacturing plant when they do some updates to the machinery. Here's another example of a retail analytics Fortune 100 retail company, right? This particular company is a large retailer, right? They have sales coming in from online and also from in-store. And all of that data is classified based on the end user needs, right? Hot data access is where the users need to interactively explore data, right? And cold data access, where latency is not important. That's where the complex analyst queries can run their use cases. The hot data use case is where we are focused on here. The retailer wanted finer granularity into digital and physical purchases. Data was summarized at monthly level, but needed weekly and daily visibility, right? And that help them achieve faster operational efficiency for the merchants. Case, for example, is they wanted to know if a 6-pack can of Coke was selling faster in a certain location or certain geography compared to a 24-pack can of Coke. And therefore, the merchants from this company could order their inventory in the right manner, right? And that's just one item. You can just imagine the type of items that these guys are selling is over the roof. And that basically was the key requirement. They had a data lake, which was a legacy data warehouse, which was too cost prohibitive to reach the desired level of granularity. Also, it was too slow to achieve the desired level of concurrency. So Imply was serving all the hot data queries. This particular customer themselves said that we were running 10 times faster over Google's BigQuery for comparative use case. That's from the customer, not from us. Right? So today, what has happened? They are actually, today they are actually having hot data queries which are completing 5 to 10 times faster than BigQuery, right? And therefore, the procurement team can interactively analyze item level sales while negotiating with each supplier. It leads up to 200 million in savings from excessive supplier charges. That's based on what they have told us the last time we spoke to them. That has increased exponentially in the last 12 months. And it's multi-cloud product enabled. So therefore, they could easily migrate from Azure to Google Cloud to reduce additional costs. That's what this customer has used us for. Today, our customers are diverse and global. They are across different industries. In this APJ region, we have customers from media, for example, like Naver in South Korea, and of course, Twitter and Lineman and Place, right? We have NTT in the networks and out of Japan. We have Atlassian here out of Sydney, which uses us to power their Confluence products, analytics. We got security companies like McAfee that are using us to power their cybersecurity products, which they provide as a service to their customers. Right? We got fintechs like Chai out of South Korea and Singapore. We have Plate Finance, which is using us, and PayPal from a payments platform point of view. So these are some of the examples that I know of, but there's plenty of other use cases out there, which I could talk forever. So please go ahead to our website, right? And before I go to our website, just a quick overview of our company. We are a 5-year-old company now. We are funded by Andreessen Horowitz and Geodesic Capital and Khosla Ventures and Bessemer Ventures out of the US. We are headquartered in San Francisco. Our employees are across all over the world. We have global customer base across many verticals, Amazon, Apple, Atlassian, you saw that in the previous slide. And the technology is proven. It's built from Apache Druid, which is a real-time analytics database as the engine, and gives you complete experience from enterprise distribution to visualization. Go ahead and get started. This is our website where you can go ahead and get started, imply.io/get started, and you can try Imply Cloud, or you can download Imply free of charge and give it a go. Thank you, and I hope you have a good day.
Thank you for that, and good afternoon, Jag. How are you?
Yeah, good afternoon, Noel. I'm good, thank you.
That's the way. I incorrectly introduced you as being based in Brisbane and a business analyst, and that I had a data quality issue there. Clearly, you're actually a senior sales engineer at Imply, and I believe you're based in the Sydney region, aren't you?
Yes, I am. No worries.
Fantastic. That's good to hear. And thank you for that fantastic talk. Interestingly enough, at last year's DataEngBytes conference, we had a presentation around Confluent. And I understand that Imply and Confluent can play nicely together, being, of course, a sort of commercialized version of Kafka. Can you tell us a little bit more about, are you finding that a common implementation of pairing up those two products?
Yeah, absolutely. And that's spot on, because majority of our customers or users of Imply Druid, they tend to analyze real-time streams, and bulk of the time, the real-time streams are coming either from Confluence Kafka or open source Kafka, or even AWS Kinesis. These are 90% of our customers, right? So yes, it's a natural fit. And it's just simply because I think the whole architecture of Druid is naturally designed to handle that large number of real-time concurrency as it's ingesting real-time data.
Fantastic. Great to hear. Can you also let me know, so how can a developer start using Druid if they wanted to get cracking on that?
Yeah. So, I mean, I didn't realize this, but I actually put it in my slides. But yes, they can actually go to our website, imply.io, and start downloading a quick start Druid setup, which they can run on top of their local Mac, or if they want, they can even run it on AWS or Azure or any cloud provider that they like. It's basically ready made for them to start ingesting data straight away without needing to understand any technicality of how to set it up in the first place. It's just a matter of downloading the executables and off you go, start ingesting, and you can start integrating it with your own custom UI you might have that you are feeding to your front customer facing SaaS solution, or you are having it for your internal users.
Yeah, fantastic. And you mentioned that Imply's been around for 4 to 5 years now. Have you found that the uptake, particularly in the banking sector, addressing issues of risk and particularly utilizing the data sovereignty capabilities of the tool, is that still progressing?
Yep. Sorry. Yep. Yeah. Yes, it is. However, I think what we have noticed is that the teams, the users that tend to adopt early, they tend to be developers. But what we are noticing is it's those developers that are working for companies that are providing solutions which are customer facing, right? And majority of them are providing solutions to, like for example, the banking use case. The developers are creating a solution for their internal analysts, right, who are finance fraud specialists, and they just need a tool from where they can do their work. But what we're discovering is the bulk of our users, the adopters, are developers who are developing apps that are customer facing, where the customers themselves need to have analytics where they can see how their items are selling, where they're selling. For example, we've got this large financial fintech company based out of South Korea right now that is providing analytics to their merchants who are using this company's solution to have cash back, so that the merchants they have thousands of merchants in Southeast Asia and also in South Korea, and the merchants can just connect to their application, which is powered by Imply Druid, and see who are the customers, where they're using the cashback scheme, so that they can plan their advertising, plan their marketing campaigns accordingly, and based on also get more details, similar to the whole Twitter use case with Mopub.
Yeah, fantastic. And I'd love to know what's on the Imply roadmap. What exciting new release features have you got coming up?
Yep, we are going to have our fully SaaS, 100% SaaS, fully SaaS managed solution up by beginning of next year, so that if anyone wants to give it a go, they don't even have to download it at all. They can just come to our website and start feeding up, ingesting data straight to our SaaS solution. That's the next exciting thing that we are coming up. And then, of course, we're also having better user interface with our Pivot 2.0, which is also going to be released beginning of next year. So a lot of big stuff happening. Watch this space.
Yeah, fantastic. And are there many local users in Australia that you're free to name?
Yep. So very proudly to say that Atlassian is one of our largest customers here in Australia, based out of Sydney, and they've been using us for more than a year now, and they clearly they see the benefits, and they are one of the top technology companies. We've also got another company which I can't name here, also in New South Wales, which uses us to power their self-service analytics for energy providers, so that when customers like you and me who have solar panels on our roof, we want to see how powerful our solar panels are, the analytics. They're using Imply Druid to provide that, and they're giving it to the customers as a SaaS solution.
Fantastic. I can really get on board with that as well. I'm about to install some solar panels, so I'll need to keep an eye out for any providers that can give me that information quicker than others. That's quite exciting. Jag, I really appreciate your time this afternoon. Great to see what some of these newer products are doing, and particularly the data in motion, and that being such a growth area, and just almost like the Wild West of data for my mind, in terms of people still coming to terms with what can we do with data as it's flowing through with these quick analytics. So really appreciate your time, and thank you.
Thank you.
Cheers. All right, thanks, Jag. So this afternoon, for our next speaker at 2:10, I'm very pleased to say that we've got Elizabeth Antoine, Andrei Zakikov, and Eleni Santorinau. So Elizabeth is the Senior Global Black Belt at Microsoft for Data and AI. Andrei is the Data Modernization Global Black Belt for the Europe, Middle East, and Asia at Microsoft, and Eleni is the Azure Technical Specialist for Advanced Data. So 3 Azure heavy hitters coming in today to speak to Albero, decision tree, when to use what, the full Azure data estate. And we've got Elizabeth on the line here. How are you, Elizabeth?
I'm good, Noel. Thanks for having us here.
No, really appreciate your presence here. Now, I've got a fun fact about you that your first time ever in water was in the middle of the Great Barrier Reef. You jumped straight in without knowing how to swim and then went and learned how to swim. You could have been swimming with the fishes on that one.
Oh yes, look, it was really a fun one and a risky one, to be honest, because I really didn't know how to swim, and being in the Great Barrier Reef, I couldn't resist myself. Just jump in and see what it looks like, and it was terrifying, I must say. But I've just taken that experience and started learning swimming as well, and I'm okay now.
Fantastic. That's magic, and what a first experience to sort of see what was under the waves. Usually, when you learn how to swim, you're trying to stay above the water, but you would have been tempted to stay below. So we've got a presentation from you today around the decision trees. Should we get underway with that?
I think so. Let me share my screen, and let me know once you can see that. Can you see my screen?
Yep, so that's come on.
It's come through? Perfect. So, as you know, as Noel actually introduced us, we actually a group of global black belts across Microsoft. We are working on an open source project called as Albero. So Albero is basically a decision tree that's driven out of one specific aspect in mind. That is to give the customers across the globe to basically get an unbiased, logical way of deciding the best fit architecture in Azure. So this is, though we are from Microsoft, we've taken a very unbiased view of actually building this out. And this has been used by quite a lot of customers globally. And there's more than 10,000 users, active users globally as well. There's big organizations who have taken this approach to adopt Albero, to create their own version of Albero within the organization. So very, very excited to present this Albero decision tree, and I've got a link up in there as well if you're interested to have a look at it straight away. So I've got Eleni and Andrei, I've recorded them talking about this, so I just want to play that as well. And before I do it, I just wanted to get you sort of a way of what are we presenting here. So we're talking about Albero, the decision tree. I want to actually start off with saying why we built it and the purpose behind that. And I also want to give you a history of, how we went about building it and what are the revisions that we came about, and some of the customer use cases as well, globally and as well as in Australia. So with that, I just wanted to play the video, the audio from Eleni talking about why we came up with this Albero decision tree.
Hi, this is Eleni, and now we're going to talk how it all started. The data space has evolved to be a huge ecosystem of services. The portfolio of databases we have on Azure for storing and processing data keeps growing, and it counts at the moment more than 20 databases. The question that is commonly asked by partners, customers, and even colleagues is how to navigate across that, how to choose the the best database for our project. One might say that the way to properly choose the right option is to carefully read the documentation that is free and accessible online in order to get and understand all features, capabilities, and limitations of the services. Well, good luck with that. If you go to DB ranking, you will see more than 350 databases. And we all know the paradox of diminishing returns on information and knowledge. Basically, by increasing the amount of information one can get, that goes increasing knowledge and the understanding. But this is up to a certain point, where further than that, increasing information creates confusion about the offering and maybe even about the problem that you try to solve. So we might use a shortcut to this approach. And what we've noticed is that usually the criteria we base our decision are not pure functional or technical requirements, but more it can be the experience we already have with a specific technology. Like I was happy with that product, so I'll use it in every time. Or preferences. For this use case, I prefer technology X. Or even beliefs. I believe that this functionality exists at this specific service, so I'm gonna go for it. But as you can imagine, there are problems with this approach. And we see that usually later in the stages of an engagement of a project, where for some reason we need to review and solve performance issues. All the above led us to create a decision tree we call Albero, with the exact amount of information needed to make a decision that simplifies the process of selecting a data backend for a project. We introduced Albero back a year ago, and since then we have more than 10,000 unique users that basically follow the principles of identifying the read and write patterns of the project. What we have in this first version is two paths. One on the top is the write and how we write data, how frequently, is it bulk or stream, etc. And the other is how we read it once it is written. Are we doing point lookups? Are we doing explorative queries? And so on. Now, a workload, most of the time, will have mixed requirements for reads and write. This means that we need to integrate more than one data services. And this is portrayed in the decision tree with the in and out icons of the data services that shows the out-of-the-box integration on Azure. Clicking on those icons, it takes you to the official Microsoft documentation. We have also created separate views for developers where you can see what is supported in terms of programming languages, versions, and sizes of messages at each service, and also a view with the security features of each data store. One of the customers that uses Albero is UBS. The CTO team took the Albero, as this is an open source project, and adjusted it to their own needs. In order to distinguish between the services, they created a color scheme to define owners and the different environments, and they are using it as a tool for the enterprise migration framework to decide where each of their workload would land on cloud. Tanya is one of the contributors of Albero, and here you can find how she describes Albero and how it helps them in their journey to the cloud.
So that's Eleni talking about Albero and why we came up with Albero, and obviously UBS using Albero internally. So Andre, myself, and Eleni, we actually are the owners of this open source project, but we have so many collaborators across the world, including Tanya from UBS as well, collaborating in terms of how Albero is used in designing and also the issues and basically improvising on Albero as well. So I've got a few examples up here that you can see that there are customers from Australia using Albero Albro as part of the architecture decision framework. This is basically, when people are not able to decide which architecture to go towards in terms of if there is a Spark, if there is a SQL sort of solution, which one they have to go after. Do they have to build everything in Delta Lake, or is data warehouse still relevant, and things like that? That's where the Albro decision tree has been hugely useful. Similar to UBS, we have actually done the same thing with Rio Tinto. So one of their major migration projects is where Albro is being used, and it's officially documented saying that the Albro has been used as part of their decision-making process for the target architecture for the migration. And Rio Tinto also are getting onto that journey of using Albro internally, which is very Rio Tinto specific. So I will actually kind of let Andre talk about it in a minute. We've created a new version where we are publishing Albro as something that you could adopt from an organization level. So we are sharing the artifacts. We've created a CI/CD approach to building this whole decision tree. So we are actually going to enable Rio Tinto to have their own version of Albro within Rio Tinto. So that's kind of the journey of some of the customers in Australia, and I've got a few logos there. There's obviously lots. Just to talk about the revisions, right? So we've got some 3 major revisions that we did in 2021, and there's lots more to come. So from a revision perspective, the first thing we did was to actually create a very simplified and a streamlined visual representation. What we realized is, though it is an unbiased logical view of read and write profiles, there is a little bit of more business context that we needed to add to the decision tree. So that was our first revision in terms of giving a layer of source applications and also the quantitative parameters, defining whether it is an ETL or versus an ELT, whether it is a application that you're trying to build, or you're trying to build a streaming sort of solution. So we added a lot of business context into that decision tree to make it more simplified. And then we also had created three or more specific decision trees. So the one that you have here that I'm highlighting is basically the Spark-based decision tree. There's a storage-based decision tree. There is a Cosmos DB-based decision tree. So if you drill down onto those specifics, you'll have a very specific storage-based decision tree, which talks about different storage blobs to ADLS, whether you need Delta Lake. So very specific to the storage concept. So we have got a decision tree that is specifically for that. And there's also the Spark options that we have from Databricks, HD Inside. There's also the options around Synapse Spark. So what we have done is we have created a drill down version of a Spark-based decision tree that you can drill down to just to look at the Spark capabilities and make a decision about which one to go after, which follows the same pattern as the main decision tree. What we also did, on top of the developer view that Eleni was talking about, we also created a security view. So added elements of security around the different security controls we have across the Azure Data Service, and added a view of the security controls for every one of these servers. So as you're making a decision as an organization, not only you're looking at the capabilities and looking at the skill sets, looking at the integrations of services in and out, you're also having a view of what are the security controls available across these services, so you can have a more informed decision about what architecture you have to go to. So that's sort of the 3 major revisions that we came about. And what we also did is created a team of community where everything is sort of logged in GitHub. We have got 110 issues that was raised over a period of time, which is more than a year, and we've consistently worked on those issues and closed those issues. Have worked on the feedback that we have actually received across the community as well. So with that, I might just ask Peter to play the audio recording of Andre talking about the newer version of Albero, please.
Thank you, Eleni. And hello, it's Andre here. So just wanted to elaborate on a few things. So first of all, on 1st of September this year, we have launched a new version, which not only includes the results of the 4th major review, but also it brings us in a fully new interface, fully new experience. And in this experience, we have put all the decision trees we have for all the technologies up front, so you can find them directly on the main page. And we have also included a short description for each and every decision tree. What's this whole thing about? There also we have added the filters and the search, so you can search on the contents of descriptions, on the tags and all. And also you can filter that by the technology, for example, be it SQL, Postgres, or Spark, or whatever it be. And also the viewpoint, like security, or development, or industry, and so on and so forth. We have also added so-called solutions gallery, so where we're working on some specific applications or specific decision trees for various industries. Like, for example, in this situation, we have added recently the IoT one. So that's a pretty good one as well. And also, we have added the materials which are supporting these decision trees and the architecture is proposed. So it's on the last section. The interesting thing about this new experience is also that now we can basically use that within the enterprises. And because it's a fully React-based application with its own CI/CD pipeline. And this also enabled us to basically share that with our large customers and ingest these decision trees, adjust them, right, to whatever needs the large customers have. For example, they might want to do the whitelisting or exclude the certain services or mark the owners there or add some specific limitations, whatever it be. So how the process now looks like, we can basically copy our React application and the static content session from our GitLab into another GitLab, whatever it be, enterprise or something, and we can share that. And then you can adjust the diagram based on, using the Lucidcharts or Visio, whatever. And then once it's adjusted, we're using the HTML map creator just to adjust the image map, because basically all of these components are baked by the links, so the links to the docs, and that can be adjusted. So for example, you can change the links to the Microsoft official docs onto the links for your internal resources, whatever, right? And then you can add all of this to your private GitLab and then adjust the CI/CD. We have the CI/CD process. Now we are publishing on Netlify, but you can change it and basically do the CI/CD to whatever location you want, right? Be it, I don't know, SharePoint server, or be it any sort of a static hosting, whatever. So that's how it works right now, and that's how the enterprises are using it right now. One more thing, so basically we have definitely, and we are supporting this version, https://albero.cloud. That's our main version. It's publicly available, right? And what we're trying to do is we're trying to make this very transparent. We're trying to make this very open. So all the things we do We are tracking them in the GitHub, in our public GitHub, because again, the GitLab environment is private, is ours, but the GitHub environment is widely opened. And now, main thing which we're utilizing there are the issues, and we're tracking and sharing every change, every single change we make. If you see that something in these diagrams is wrong or missing, or you have any sort of a question around that, right? You want to know why the certain decision was recommended, or you want to propose an alternative decision or an alternative, I don't know, way of making these decisions, just simply raise an issue, and then we will take it from there. Thank you so much, and with that, I will pass the word to Elizabeth for the closing notes. Thank you.
Yep, here's some of the free sort of training materials available as part of Microsoft's so compete in a cloud skills challenge, and there's also a request for $100 USD's Azure Pass that you can apply for. As a summary from an Albero perspective, as you know, this is an open source. We've invested a lot of time. There's lots of discussions that we are having within Microsoft, within the engineering team, and outside of it as well, as we actually come up with these sort of decision trees and some of the recommendations that we are proposing. So ultimately, this is an open source project to give the customers an unbiased, logical way of deciding what is the best fit architecture for them for the solutions that they are trying to build in the cloud. With that, I would just want to wrap it up and pass it on to Noel.
Thank you, Elizabeth, and Eleni and Antoine. Thank you very much. That was fantastic. I was loving every moment of that. It did remind me that I do need to buy a bigger monitor so I can fit the entire decision tree on it from end to end. So first question, where did the name Albero come from?
It's basically a name that we actually came up with, like to sort of give you that it represents the decision tree, obviously, right? So it's sort of a Italian sort of a name that represents that sort of notion of decision making, and so that's where the Albero kind of name came up with. So it was just us deciding that probably that's the right fit name for this.
Great, and it appears from what I saw of the detail there, but you had things like Spark and NoSQL, Databricks, CosmoDB, of course, being the Azure NoSQL offering. So there's a lot of different use cases that you can pump through this decision tree. So it's not just application hosting, for instance. It's whether it's data transformation or serving. I'm assuming Event Hubs is on there as well.
Yeah, basically we are covering the end-to-end data AI sort of estate. So it's not just application specific. We've got specific decision trees that's for streaming. So the overall decision tree, if you look at it, as you rightly said, it's like huge and massive, right? It covers the aspects from streaming. It covers the aspects like ETL versus ELT. It talks about aspects around the SQL side of things from an application perspective, obviously. The NoSQL side of things as well. So we've actually brought in a lot of different mechanisms of building these solutions across the board. And one of the things that we realized along the way is this: when you give this massive sort of decision tree, though it has everything, it can be a little overwhelming. And that is why we started building this very technology focused decision trees, which is around Spark, NoSQL, streaming, those sort of concepts. But we also started building very solution specific decision trees. And if you go in there, you will also be able to see an IoT sort of specific one, which is talking about how do you build an IoT solution within a customer. So I'm giving you different options and going through the same mechanism of the decision flow.
Yeah, and that's such an important piece. I find the decision tree is not just good for the decision making, but it's also excellent for the stakeholder engagement and management. So you can actually prove out or explain your thinking in terms of your technology choice. You can essentially step back through the decision tree in front of your stakeholders to explain how you came to a result, which I find that transparency is really valuable. to getting people on board for these decisions. A question: have you got, or are you thinking of creating a transformation tooling, so ETL or ELT, the T in transformation, a tooling decision tree?
It's actually already there. So we've got the ETL versus ELT decision tree built within the the main decision tree, and also as the technology focused decision tree as well, which exactly goes into that concept of transformations. And in fact, I guess this is one of the main topics that's been there across organizations. Say, for example, UBS or Rio Tinto, right? Because it's globally, it's a global organization, and there's so many business divisions, so many users who are actually trying to onboard into cloud and trying to come up with these architectures. One of the things that they often get into is lots of POCs and pilots, right? Every business division is trying to do the similar POC and pilot, and specifically for data analytics, for transformation side of things that you're talking about. So, and that's where this is sort of like we thought that, giving them their own version of Albro decision tree within the organization would make really good sense, because then they don't have to prove out the same architecture for every business division. They have to prove it once, and they can sort of reuse the same architecture, and that's where it's pretty powerful for UBS or Rio Tinto.
Yes, absolutely, and it means that you can get to your decision quicker rather than having to go through a lot of sort of dead branches that you have no interest in. Out of interest, how does one go about getting an organisation customised Albro decision tree? Is it simply a matter of just downloading a version of it from GitHub and transforming it yourself?
That is that way of doing it, but you can also raise a request directly to us. Like, you can reach out to either Eleni, Andrew, or myself, and we can actually go into explaining you what it takes, and we can share the artifacts and the GitHub sort of process of creating your own version of organization specific Albro decision trees as well. Happy to help.
Yeah, wonderful. And a question, very technical question. Are you allowed to use this as a live resource during the DP203 certification exams or the solution architecture exams?
I'm not sure whether
I'd assume not.
Obviously not, because this is being used in the technical enablement sessions internally within Microsoft, specifically for that reason of certifications, right? But obviously, that'll create a lot of problems in terms of fatness. So yeah.
But yeah, in terms of a study resource, it's excellent, because it just sort of conceptualizes everything easy to remember for the certification exam. So that's really appreciated for all those about to sit or will be sitting that exam. Okay, fantastic. I'm just looking at the chat now, and also the Slack and internal chats that we've got for additional questions. Elizabeth, I'm interested to know that obviously the data landscape is changing at such a clip. It must be a challenge for the team to keep up to date with all of the new data estates that are being created or updated within the Microsoft ecosystem?
Look, the whole process of Albro was for simplification, right? We actually are very specific in how we are going about in terms of that decision-making process, the read and write profiles, and that's not changing hugely in terms of the capabilities of read and write profiles, right? But as you rightly said, there's new features coming. There's new capabilities that are enabled, like for example, data wars and things like that came into the picture. So we have this as a regular motion, as you can see in our presentation as well, that we actually raise a lot of issues ourselves in the register when these major updates come about, and we go about a practice of actually resolving all of them, making sure that the decision tree is always up to date.
Yeah, fantastic. That's such a handy resource. And I want to thank again yourself, Yeleni, and Antoine for all of the efforts that you've put in, and also the presentation of this. I think it's your first appearance at DataEng Conf, but we'd love to have you back next year for version 5, 6, or 7, whichever version it's up to by that stage, and any more innovations that you've created in this space, because it's an extremely handy tool. Just as we and a nice link back actually to day one's presentation from Maxime during the rise and fall of the data engineer. He spoke about the data engineering landscape and just the hundreds of components that we have available to us, and anything that simplifies that and allows easier navigation through that complexity is really appreciated. So thank you, and I hope you have a wonderful afternoon.
Thank you so much, Noel and Peter, and for this opportunity. It was great presenting to the wider audience, and happy to be back as well. And thank you so much for the opportunity. Yeah.
Great. Thank you, Elizabeth. Appreciate it.
Thank you.
Okie dokie. So this afternoon we've got our final lucky talk for this afternoon, which is a talk on scaling proximity targeting via Delta Lakehouse-based data platforms ecosystem. So we've saved the best till last. We've got Rohit Shrivastava, who is an engineering lead with expertise in working on programmatic media buying space for AdTech domain, and Bikash Singh, who is an MIQ Digital India technical lead. So they'll be speaking about proximity targeting, which is a marketing technique that uses mobile location services to reach customers in real time when they are around a store location or point of interest. This is done by defining a radius around a specific location, and if a customer has opted into location services on their mobile phone and enters within this radius, then that proximity targeting can help in triggering an advertisement or a message to consumers in an effort to influence their behaviour. This can be combined with the ability to purchase impressions through programmatic ad platforms that are powered by real-time bidding, which can help businesses formulate the right strategy of influencing their users on a particular geographical area. So without any delay, we'll hear from Rohit and Bikash on their presentation.
Hi everyone, hope everyone is doing safe and well. Myself Rohit, and I'm accompanied by one of my colleagues, Vikas. So I'm one of the engineering leads at MIQ, and Vikas is one of the technical leads. We both are part of MIQ's team, which is called as Data Analytics. This team is responsible for building the entire data engineering stack, as well as building the data products combined together. I would like to start by thanking the organizers for giving us an opportunity to present in a wider forum. Today we are going to talk about a topic that we have been working from last 6 to 7 months, and this is called as scaling proximity targeting via Delta Lakehouse-based data platforms ecosystem. Right. So starting on with a brief introduction, who are we? And when we say who is MIQ, so MIQ believes in a sole vision of reimagining the value of marketing. To kind of briefly in a sweet and short summary, we are basically an ad tech company, and we enable people in the space of programmatic media buying. In a simple words, you can think of all the clients and the agencies who are actually into the ad tech space to be clients for us, right? A very simple example that I mostly take to define what we do is think of the US elections that were done last year. And in this case, let's say a Trump or a Joe Biden campaign analysis team would be a client to us, where they would come and say that, can you go ahead and drive the number of reach for a particular state like California? Can you try to see if we can increase the media spend by X amount in a state like Boston, Chicago, etc. So yeah, that's a very short summary of what MIQ does. Moving on. What do we do? As I said, we are mostly into data analytics company, and we try to bring in our data products as well as the AI smartness into the marketing stack. We have 3 product offering. One layer is called media, another one is analytics, and another one is tech. Talking about media, it basically is responsible for fueling your brand growth and increase your ROI as much as possible. So you can, the example that I mentioned, in which case you can think of Trump's team or Joe Biden's team coming to us and saying that this is the media, this is our target, and we want us to increase our reach by X factor. So that is in an absolute term is called as campaign management. And this is our media stream, where we work with multiple agencies and clients who come to us and try to tell us the definition of a campaign, and we would work towards making that campaign a success. Second stream is analytics. Again, pretty obvious. So we offer data analytics as a solution, which means that clients can come give us a use case, and we would use our smart analytics and AI solutions to make sure that we kind of provide them with the real outcomes in the businesses. Third unique offering is tech, where we kind of provide both product as well as services in this space. You can think of, again, that we take your data, we apply our data engineering, data science, technology, real-time bidding, and multiple products and services that we have built to, again, derive the best ROIs possible from our clients. So yeah, in a sweet summary, three basic core offerings: media, analytics, and tech. Today, moving on, we are going to cover very specific about a product that we have within our media stack. So within our media, we have multiple products, and there are multiple features that it tries to meet. Within the product stack, we have something called as Motion, which is also hyperlocal. You can think of Cast, which is also called as TV solution. You can think of Predict is our predictive retargeting solutions. So what we have done is we have created small products in the space of all ad campaign strategies. One particular product for TV strategy, one particular product for your location strategy, one particular product for your prediction strategy, right? And what we are going to talk today is a very specific use case that we solved using our data platform ecosystem in the hyperlocal space, which means that how our location-based products are enabling our clients to drive more and more revenue through the location of the particular individuals. Moving on, location is powerful, and I hope I can say that is true in current scenarios. But we all know that in case of COVID, this location is not as powerful, at least, I mean, how it used to be at least a year ago. But having said that, I mean, what we had realized about a year back is that location-specific campaigns are twice as effective than a non-location based campaigns, right? Today, people are, I mean, pretty much around the places, and they're using multiple channels like your mobile, your tablets, your TV, and a lot of things depend on how people are moving around, right? Think of a situation where you are in a particular place looking for a shoe, right? And you went to an Adidas showroom and you're looking for a shoe which is a latest release for them. Think of a scenario where you get a sudden real-time message or real-time kind of ad displayed on your mobile, where it says that the same shoe is available in a vicinity of 100 meters in a Nike with 15% more discount or 20% more discount, right? And that's the vision that I'm saying, that location is powerful. You can imagine that how it enables individuals as well as companies to kind of derive better ROIs from whatever they are trying to target. Location is powerful, definitely. What technical term in ad tech we use is something called as proximity targeting, right? Which is basically dependent on which area you are located in, what is the proximity, how we can target with the best suitable ad for you. There are three core pieces to this strategy. The first one is definitely find. So basically building a smart intelligence data analytics solution where you can find the location of the consumers, right? And what they're trying to visit and how often. So here, ultimately your frequency of visit and your uplift in terms of what you're trying to visit is quite important. Hence, we definitely are specializing in building some solutions where we are able to find the location of a particular consumer very quickly. Second domain is target, where you have to understand as well as target your audience also correctly, right? So here, understanding the individuals, understanding their emotions, understanding what have they been doing in their historical presence, that is very important. And based on that, you need to understand the sentiment of the user and kind of try to target based on the location, what can act best for them. So this is the target domain. Last one is measurement. At least in last 5 years, measurement has become a very important piece in the ad tech world, which means that it's not only about targeting or finding. It's also about making sure and measuring whether the target that you made, how much of an uplift or how much of an incremental lift that brought to your campaign or your revenue, right? So which means that all three domains, which is finding, targeting, as well as measurement, is quite an important concept when it comes to the proximity targeting. Moving on, I've just spent maybe 30 seconds on explaining what proximity targeting is. So no custom definition, but some algorithmic definitions of how we interpret proximity targeting at MIQ. So what we usually do is we identify a particular location and start creating radiuses around it. What we try to do is we create a 150-mile radius first, try to figure out based on our at least 7 to 8 different data sets to identify if there is a particular user or a particular brand for which we are trying to run a particular campaign is present or not. We do sometime real-time targeted as well, but that depends on the campaign of the nature of the campaign. For example, we would not target a devices the moment we identify if the campaign is not an event-based. When I'm saying event, it means the real-time campaign. If the campaign is real-time, we would actually target the user the moment we find. If we don't, we kind of do it in a batch mode where we try to understand the user related to their 90 days or 180 days of a journey, and make sure that our impact and the target audience is right. So we start with 150 mile. We kind of try to build that blast radius as much as possible, and we create multiple radius points subsequently. So we start with 150, then we would build it for 500 meter, 1000 meter, 2000 meter, 5000 meter, and these are the radius we keep on trying to increase and try to find the user. Now, the ultimate aim of this definition is to make sure that we drive the footfall for the devices as far as possible. I mean, for obvious reason, it doesn't make sense to target a user which is, say, 10 kilometers away from the store, right? And hence, based on different campaigns and the nature of the definition that client has given us, we try to derive the best possible footfall. And footfall is a technical terminology here used to basically measure the success that you brought to a location campaign. Moving on, so just a quick process as in how do we do. As we said, we target the users in the vicinity of the client store, which means that here, let's say our client was Nike, right? And Nike wanted to increase the sales of their recent basketball-based shoes. So what we do is we kind of know where all Nike stores are. So we try to understand the users in the vicinity of those Nike stores who are interested in buying those kind of shoes, either at the point or they have also shown some significance of that in the last 90 days or 180 days of their activity. Now, their data to us is not only available from this particular data set. Because we talk about various data sets that we integrate, and there are various ways in which we can identify that users from various other channels to understand the sentiment as well. So yeah, that would be the step one, where we target the users in the vicinity of the client store. Second would be target the users at the conquest location. So conquest locations typically means your competitor stores or your transparent locations. For example, if the client was Nike in my case, I would actually try to look if there are Adidas based or let's say any other shoe based store also in the vicinity, right? And try to again read those users through our various smart and intelligence data set mechanisms and try to identify those users as at the competitor locations as well. And then, as I said, the last one is, unless it is not a real-time campaign, and if it is a historic or a batch campaign, we also look at the sentiment of that particular user for the last 90 days. As I said, for us, identity is important, right? And when I say identity is important, a single user could exist into our system in 12 different ways. Now, identity is a different offering from us where we would try to identify a particular user across 7 different data sets to create its unique journey and unique identifier, right? And based on that, we'll not only know the user's location intent, but also what the user has been doing in the last 90 days across various things like channels, their browsing history, their site domain visits, the keyword that they have searched, right? So it's a combination of all those three, which would actually help us increase the footfall with the proximity targeting. It's a very brief summary of how our algorithm typically works. What ultimately we offer to our clients, we provide them daily visitations, which means that an analytics into who are visiting into their store. Uplift, which means that how their incremental lift and measurement strategy has worked. Like when they started from us, their visitation was 10 users per store, and has they increased to 10x or 3x or 4x into their store. So we provide that kind of insights. App insights, we definitely also provide to our clients in terms of which is the channel or which is the app through which the most visitations have been done. Is it desktop, is it tablet, is it mobile, what exactly it is. Top locations, which means that if, again, Nike in the context of the discussion that I'm doing, if there are 10 different stores, which particular location-based stores are trying to enhance more, where they should go ahead and invest their ROI to make sure that the reach is higher. Top strategies, in typical programmatic media buying, when you target a user, we call it as an activation. And in order to activate or target a user, there are multiple strategies that you can use. So based on whatever analysis that we have done, we would also go back to the clients and provide the various strategies that we have. Frequency analysis, again, quite obvious that we also provide a user-based frequency analysis to the clients too. So these are the end result of the hyperlocal solution that we try to sell to our customers. I would pass it to Vikas, who would actually try to explain whatever I have talked through with a real use case that we tried to solve recently for one of the clients. And on top of that, also what were the technology challenges that were faced around that, because the data is pretty huge in terms of both variety as well as the scale of the data. So over to Vikas, who can take us through the interesting journey of how we solved a scalable solution for one of our clients.
Thank you, Rohit, for setting up the context on proximity targeting. Next, I would like to showcase how we utilize proximity targeting in order to drive footfalls for one of the clients that reached out to us. So it was a typically high street electronics retailer from UK, which wanted which wanted maximum users to visit their stores because there was a seasonal discount that was going on, and they wanted the users to view that seasonal discount and visit their respective location stores. So before that, a typical glimpse of how the daily usage of data looks in case of MIQ. So we typically serve across like 2,000 campaigns, which serves 90 billion ad impressions and reaching out to 750 million different users. All of this together generates around 30 plus terabytes of data. On a spectrum of how this data looks like, we mostly ingest all sorts of data ranging from device data to GPS data to location as well as audience-based data. And in order to solve this proximity targeting problem for that client, we use typically around like 4 to 5 different data sets from location, from like factual and audience related data sets. So this, we have our internal processing platform that was built for solving any sorts of platform use cases. So this platform typically ranges across 5 different verticals like prepare, learn and deploy, execute, test, monitor. All of these verticals are backed up by a microservice, which is built on top of big data vendors like DataEngBytes and Qubole. So on a daily basis, everything that we do in terms of 5 these verticals is mostly being actually done by a wrapper, and this wrapper is sitting on top of the REST APIs that are exposed from the DataEngBytes and Qubole. Now, in order to solve that problem for the client, we actually took help of 5 different data sets ranging from like AdSquare and TomTom, which mostly provides location-based information based on latitudes and longitudes. The Trade Desk is mostly DSP, which provides real-time auctions of what are the different auctions that are happening on the real-time bidding platform, as well as we also utilize the bidding data from AppNexus. All of this data were ingested into our data lake, which was backed up by Amazon S3. From Amazon S3, we typically pulled out the data, wrote a different DataEngBytes pipeline, which is mostly written on PipeSpark, and the output of that pipeline was again then dumped into Amazon S3. Now, from this point, this was used for 2 different purposes. One for showing insights across how this actually campaign was driven throughout this journey. And this insight was backed up by Tableau dashboards, which were eventually sent to that client, as well as we use this output data for our internal MIQ analytics purposes. So before diving into the details of this, I just wanted to highlight a particular a main concept that is being used to tackle this problem. So right now, if you can think on the left-hand diagram, there is a yellow GPS, which mostly think of that GPS to be any of the stores. Here, in case of think of this to be a McDonald's store. Now, what we want to highlight to this problem is that we want to capture all the devices that are falling into this particular vicinity of the store. Now, this vicinity can be of different radii, ranging from 150 meters to different kilometers to many kilometers. So in order to find out the total number of devices that are falling into this region, we took the help of a popular geocoding technique called GeoHash. So GeoHash mostly what it does is that it typically divides the entire globe into different small tiles. This tile is mostly geocoded in terms of alphanumeric characters. So each of the alphanumeric characters represents a certain dimension of that tile. So using this geohashing technique, we divided the entire vicinity of a particular store into geohashes. So we took the smallest geohash of 7 characters. So 7 characters of geohash represents 150 meter of a tiles, mostly a square tiles of that dimensions of 150 meter. Now we divided the entire geography into different geohashes, roughly in the form of this visual diagram here. So let's say given a particular area, it will be consisting of a multiple geohashes, Now what we need to find is that of all the impressions that are being served, so a user might have been seeing an ad on his mobile, and upon seeing an ad, he might be visiting the particular geo store. So he might be actually landing into the geo store, or he might be coming across the vicinity of this. So we want to track all those users. Now, in order to track all those users, we need to have those data that which of those users were actually shown the ad. Now, this data was provided to us by the different auction data, which typically we got from either AppNexus or Trade Desk. So this is a typical representation of how this data looks like. So it consists of the device IDs as well as the latitudes. Now, one reason to highlight is that we cannot, a latitude and a longitude represents a certain point in a geography. Now, if you want to highlight a particular area, then latitude and longitudes are not handy tools. So that's where we kind of explored different other geocoding techniques, and GeoHash was one such technique which helps us to know what's the area, what's the geocoding that is available for a given area. So what we typically did is that we kind of ingested a new GeoHash column, and in order to find out how many of those devices actually fell into that area, we joined we joined the data from the store location as well as the data that we are getting from the auction data. Now, the result of this was that we typically found out of all the users whom we actually have shown them at, how many of them actually landed into that store, or either landed into the store or came into the vicinity of the store. Now, what are the challenges to this problem? So the challenge was that the data size was used. So the auction data ranged from 108 gigabytes, whereas the store locations were roughly on the range of 100 megabytes. The device mapping, which was the result of this join, the result came out to be 98 gigabytes, and which were joined with further locations data. We did some sort of filtering and finally the aggregations. So these aggregations were ultimately which were backed up by Taboo dashboards. Now, the first challenge was that it was in order to run the entire pipeline, the amount of time that it took us was around 11 hours. We'll come shortly that why it took 11 hours. It also resulted in a sudden spike in cost, which resulted in like $25,000 per month just to run this entire data pipeline. And as a result of which, if we had to join this with other location-based providers, this was not scalable because the join between store locations and auction data, it would break as the auction data would increase. So this typically represents of the kind of connections that we have across this entire data pipelines, the kind of lineage that has got built up through this data pipelines. This with the first view, it may be very complex. So that's where we had to go and debug that what could be the blockers for running this entire data pipeline. And we found out, we dissected all the blockers, and then we kind of refactored everything. We reused all the logic that were actually being used to solve those joins. And then we have rewritten the entire data pipelines into different modules. And now we're basically speaking about those modules now. So the kind of optimization that we did was that we instead we scaled the geohashing techniques. So what it typically means is that the geohashes are mostly that we use was typically a Python functions, a set of Python functions, and the Python functions that we're using was mostly through Python UDFs in our PySpark code. And Python UDFs are not at all optimized. It's because of the data transformation that happens between Python context and the Spark context. Because Spark context being backed up by JVM platform, whereas the Python context is a completely different new set of platforms. So the data transfer was mostly causing a real time-taking process. So that's why we kind of converted all the Python UDFs into Scala-based UDFs. This mostly kind of results out how we mostly converted it. How can you use a Python-based UDF as a Scala UDF? So you typically register your Python UDFs in the form of this. You first write a function, and then using the UDF function from Spark, we can register it in the Spark context, from where we can utilize it in the remaining PySpark code. The GeoSS was mostly skewed. So when we found out that when we were joining the store location with the auction data, most of the devices were getting skewed across one of the geo columns. This mostly represents one of the location IDs, where most of the data was getting skewed. And we typically utilized one of the, since this problem was written on Databricks, so in the entire pipeline was written on Databricks, we utilized Databricks skew hints, as well as we played around the property of spark.sql.shuffle.partitions, which kind of rebalance the distribution of data across all the partitions in Spark. And with this technique, we kind of got some improvement on the skewed data, and our pipelines kind of got some enhancement with these techniques by using these techniques. Next, we used caching and broadcasting. These are typically some of the most data engine optimizations that are used widely. So as we saw earlier, the kind of lineages that we had in the entire data pipeline. So due to those long lineages, our pipelines we used to break midway. So that's where we introduced DAG barriers in between, where we mostly persisted some of the recomputed data into S3 and then reread that, and then have those data reread across downstream those pipelines. Next, we use broadcast. So we later realized that the store location data was of the order of 100 megabytes. So instead of having both the store location data as well as the auction data being joined through a normal shuffle-based join from Spark, we kind of had the intuition of broadcasting the entire store data. And that's where we kind of got the major enhancement. So from typical running the entire pipelines from 11 hours, our pipeline significantly was reduced by 50% of the time. So this was not the end. So we upon this journey, we also realized that Spark 3.0 has been released. So we kind of harnessed few of the benefits of Spark 3.0. Mostly like coalescing the shuffle partitions, switching join strategies, and then optimizing the skew joins. So the first thing that we did was we migrated all our Parquet-based data. So all the 5 data sets that we consumed for this entire data pipeline, we kind of migrated all those Parquet-based data to Delta Lake. So Delta Lake is like sort of a transactional layer which is built on top of Parquet. So it has been open source, but Databricks has also their own version of Delta Lake, which is kind of more optimized. So we had all of those data from Parquet being migrated to Delta Lake. So there is a small snippet of function which we can utilize to convert our Parquet-based data into Delta table. So now what happened is that when we migrated all our Parquet-based data to Delta table, all the smaller computations that used to take roughly around like half an hour got reduced to 3 to 4 minutes. Those were mostly the lookups kind of data which stored the historical computations. Now there is a delta Z ordering technique by which what happens is that, so if there is a randomization across your entire data, what the delta Z ordering does is that it realigns your data into the logic, into some sort of logic where mostly what happens is that when you are reading your data, you can skip the data which is no longer required in your computation. So this was another technique that we used. So after migrating our data to Delta, we have them Z ordered, and that's where we also received some amount of optimizations through this Z order. Okay. So after doing all of these optimizations, so what does success look like? So as we can see here that the entire pipeline that used to take 11 hours to run earlier, now it takes around 1.2 hours to complete. So the cost has come down significantly from $25,000 per month to $4,500 per month. And all the products that were backed up by proximity targeting used to generate a revenue of around $21 million yearly. As a result of all of these optimizations, ranging from skew join to geohashing, shuffle partitions, and cluster optimizations, we have been able to be profitable by a margin of $2 million. So this is on a yearly basis. Lastly, I would like to thank all the organizations for giving us an opportunity to present our use case across this wider forum. And now I'd like to open for question and answers. Thank you.
Awesome. Thank you so much, Rohit and Bikash. That was a really nice presentation. Really enjoyed all the insights of building out a real-time streaming solution. So thank you so much. I guess you're not available to take questions. That's perfectly fine. We might just sort of slowly bring the conference to a close. Actually, no, we do have Rohit on the lines. Sorry, Bikash. How's it going? Awesome presentation.
Thank you, Peter. It was glad to be here presenting this use case. Thanks for this opportunity.
Yeah, no, you're absolutely most welcome. So, what are some of the learnings that you got out of, this building out this solution? Using Delta Lakehouse and a whole bunch of variety of technologies. Like MLlib. Event-driven microservices based on Kafka and the like. What are some of the, I guess, pain points that you found and how you sort of overcame them?
So the first pain point, mostly that was around how we had architected this pipeline initially. In terms of, so there was a lot of cyclic dependencies that was happening around the pipeline, due to which debugging was a critical item for us. The pipeline used to run for more number of hours in terms of the cluster usage, the kind of resources that it was utilizing it. So all those aspects were difficult to debug initially, but post the refactoring phase, we found it pretty easy to debug. We sort of introduced all those data engineering principles, data engineering optimizations, and this has actually led us eventually made the pipeline to run in an optimized way. So yeah, I mean, the important learning would have been how to write the pipeline in a modular fashion, how to employ the best data engineering optimizations while you are writing these pipelines.
Yeah, I can imagine, good logging practices and alerting and monitoring and things like that. But, I guess a lot of what you're dealing with is in real time. So, spikes in traffic and scalability issues and things like that definitely come into play. I wonder, like you've used a bit of a ad targeting use case here, but can you see like potentially any other use cases using this sort of solution? Almost feels like, in the current pandemic that we're living through currently, perhaps, contact tracing and the like, could definitely benefit from some of these sorts of technologies. And are there any other clients that have sort of approached you for a similar sort of use case?
Yeah, certainly. I mean, since the COVID restrictions have sort of eased across various markets, so we have seen various other clients who are currently approaching for these solutions. And right now, as of now, we are running the hyperlocal campaigns for 10 different clients on on Google DV360 bidding platform.
Yeah.
So yeah, I mean, definitely, I mean, for the first initial 2 years, the amount of clients that we had was less, but since the restrictions have now eased, we are slowly getting an increased attractions in this platform.
Yeah, awesome. Well, thank you so much, Bikash and Rohit, for your time today. It's been a wonderful presentation. It's been a wonderful 3 days. So thank you.
Thank you, Peter. Thank you, everyone, for joining in.
Wow, what a 3 days of data engineering it's been. It's been immense. It's been immense to organize. It's been immense to participate in. So really, thank you all so much for joining us and sharing in the knowledge. Massive thanks to all of our speakers. Everyone that's been involved. It's a really long process, and it was great to finally bring this to you. I know we promised that we'd get it to you live and in person, but, you know, it just didn't quite work out that way this year. But, you know, let's hope next year sort of allows that to happen. I wanted to just thank the organisers once again. They've just been incredible. We've got, you know, Nitish Matthew from Afterpay, Ingrid and Zola from Shipit, Rowan DePellier from Atlassian, and Jess Flanagan from Decade Technologies, all part of our organising committee. And then we've got Aditya Najala from OpenPay, Claudia Silva Cabrera from Kinesso, Rafael Mello from CultureAmp, Noel Hansons from Lifeblood, Helen Anderson, AWS Data Hero over in New Zealand, Leo Hoare, Simon Aubrey, Principal Data Engineer at ThoughtWorks, and Kelly Hotter, running sales at DBT Labs for the APAC region. Finally, I just wanted to do another massive shout out to our amazing sponsors. It takes a lot of work and a lot of funding, I guess, to put these conferences on. So, you know, these sponsors have been amazing with their support of this community conference. So really do thank, you know, Snowflake, Fivetran, Databricks, Microsoft Azure, Amazon Web Services, Imply, Versa, a Fujitsu company, DBT Labs, ThoughtWorks, HighTouch, Microsoft Reactor, Yao Conferences, and Cloud Shuttle. So thanks once again. Really appreciate all your efforts. Really appreciate all the engagement, all the discussion that we've generated throughout this conference. Hope you've learned as much as I have about data engineering in the last couple of weeks or last couple of days. I'm sorry, but yeah. So let us know how you think it went. You know, if you think that you know we can improve things for next year, and what sort of content that you'd like to see. All of that feedback is really welcome. So happy data engineering, folks. Ciao for now.